Okay, hello everyone. Hopefully I'm coming across. Thank you for joining us. My name is Kyle Cartwright. I'm technical manager here at Westeck. I'm also chair of the Pacific chapter, FenCan. So I just wanted to say thank you. A couple quick points. There's exits all around, as you can see. Feel free to crank a bay door if we have to. Washrooms are just down here to my left. Shoot some signs. 12 o'clock, we'll have lunch in the area here. We can come back to our seats and eat. I think throughout presentations, uh, objects, I will entertain all questions. If you have any questions, facility, we have other Westeck employees manning the doors and to the side here. So please feel free to ask and we'll point you in the right direction. Loosely speaking, we're here till 1:30, and then our session will be down for the structural demonstration down to our plant 2, which is door shop. It is a short walk away. Some of you may have passed it on the way here. Parking is still over there at Cal Tire, so we can hop in our vehicles and go down. There will be parking there, or we can just walk weather dependent. So we'll do that. And then also mention that our showroom at our head office at 8104 Evans Road is open from 3 to 5. Please feel free to stop by. Freshly redone. We have some new products there that we're launching, so I hope time permitting everybody can show. There'll be some sales reps there to point you along and answer any questions as well. So thank you for coming. I'll pass it to Terry and we'll get started.
Morning, everybody. My name is Terry Adamson. If you don't know me, I'm the technical director with Fenestration Canada. And this is very much like old home week for me. I worked for Westeck for 21 years. So a lot of familiar faces and familiar environments. So really happy to be here today. I'd like to just quickly mention, we have Stéphane Labelle, who is the FenCan Executive Director. So if you have questions about our organization, great guy to talk to. Mario is our AV fellow. And then we've got Isabel in the back corner. Isabel, put your hand up. Isabel, she never listens to me. She's our member services. If you have any questions about membership, she's your go-to. And then we have Lane, our operations manager. Lane, put your hand up. And Lane is the answer for everything. So if you have questions that nobody can answer, she's the one to talk to. So I would like to thank Kyle, of course, Kyle, the chair for the Pacific chapter of Fenestration Canada, for inviting us to come here. They've done a fantastic job. I mean, there's cookies. I mean, come on. Great job. Thank you, Kyle. Appreciate Westeck's support, FenCan. Will, thank you very much. Will in the back, Westeck's GM. Thanks for having us here. And the Westeck staff that did all of this, we really appreciate everything you guys do. Our sponsors for this event, of course, Westeck, Sherwin-Williams. Maria, put your hand up. Sherwin-Williams Paint, and forgive me, I forgot your name. What's your name? Thank you very much. Pref ERP, I don't believe they have a rep here. JSA Machinery, Martin, right there. So if you're looking for some automation, he's your go-to. And then Amesbury Truth, but we never talk to them, so don't worry about them. Oh, there he is. Didn't realize you were here, Scott. So thanks to everybody. Murray Frank from Building It Right is providing all of our audio video today. We really appreciate their support. And we're going to hear from Murray a little bit. Murray's going to tell us stories about the industry that are always entertaining and always educational. So stick around for that. So what we're going to do, I've got a little bit of a presentation that talks a little bit about the new BC Building Code and a couple of other things that might be of interest to manufacturers here in BC. And then we're going to have Murray, again, is going to share some interesting stuff, as always. And then Kyle and David Vadocz from RDH. They are going to do a session that looks at the relationship and the processes of engineering products that are under the scope of NAFS, and you know what they go through to get to those compliance requirements for those products. Westeck does a lot of that kind of product that is outside of the typical what you can test, and RDH has been a great supporter of helping them work through that process, and they're going to share that with us today. So if you could give me my presentation. Okay, so the BC Building Code that we just got, BCBC 2024, and some other good things that we'll talk about. So next slide, please, sir. No, actually, where's your thing? That's to the right, it moves it. Oh, no. So what I'm going to talk about, the launch dates, which I just told you, March 8th, 2024 is when the BC Building Code launched based on the NBC 2020. And then I'm going to talk a little bit about combustible, the engineering change in the national code, WOCDs, glass as guards, and the step code, and then fall protection, what the rebate programs are happening in BC, 2020 change, public review, and then the Energy Star participant agreement changes that just happened. There we go. Okay, I've said it several times. We're going to see the changes in BC for accessible coming next year. I believe it's March. Maybe you can confirm that. Accessible changes March of 2025 to the BCBC. The current launch for the BCBC is based on your permit application date. So put in an application to build after March the 8th, you're under the new code. Step code update came into effect May 1st, 2023, and work is well underway for the 2025 BC. Public comment is currently open right now until April 29th, I believe it is. I believe I can get into that a bit more. The next step code update, not confirmed, but they are sort of telling us that we're looking at 2027 for step 4. And then 5 by 2032-ish. So the next BCBC update, we anticipate 2028. So as per the harmonization agreement with the provinces and federal government and the national code and its adoption, this current round that was the NBC 2020, provinces were to adopt or publish within 24 months of that launch, and that was 2022. So now we're seeing 2024 March. Most provinces, some provinces have now published or adopted. Some provinces are still holding out. I know that Ontario has said January 2025, Atlantic Canada, January 2025. Alberta just launched their version, their edition of the NBC 2020 just a couple of weeks ago, I think it was. And Quebec is still on the 2015 NBC, and I can't get anybody in Quebec to tell me what their plans are to update to the 2020. Did I say 2020? They're under the 2015 right now. The BBBL, they're talking about early 2025 to have their update published that would be based on NBC 2020, BCBC 2024. So BC did not adopt the change under the 2020 NBC that impacts engineering of NAFS product. So products in the scope of NAFS can still use Part 5 engineering path for compliance in British Columbia. It's worth mentioning that the scrutiny of engineering may increase as the NBC change has received a lot of interest. So what happened, I think I get into it a bit here. So what happened is in 2020 NBC, they made a change that said windows, doors, skylights, and their components shall be designed and constructed in accordance with Article 514, 5456, where they are not covered in the scope of the standards in 5922, which is NAFS. So if you have a product within the scope of NAFS, and there's an extensive list of what those products are, under the NBC 2020, you can't engineer those products. That's what they're trying to do. That's what they're trying to say. Now, if you dig deep enough into NAFS, there are some loopholes to get you through that if you know where to look and who to talk to. But that's what they've done. It was a change that was made in the 2020 NBC after the public review by people that will go unnamed. And it's caused some consternation for a number of people in the industry that did not know that this change was happening until we actually saw the 2020 NBC. All of that said, Fenestration Canada raised this with BC, Building Standards Branch, as soon as we saw it, and they opted to not adopt that language. So the current BCBC still leaves an open path to use engineering of NAFS products for compliance. Yeah. Right. There's a can of worms for you. David can tell us. Problem. Null and void. Well, there's a white paper just waiting to be written right there. It's complicated. Didn't get any of it. You know what? It's really important actually. So I'm going to get you to repeat that so we get it recorded or at least summarize.
So in covering the term not covered in the scope, the issue is what do they define by scope? Because in NAFS, there's a section where it says product not intended to be tested to NAFS, and it lists curtain wall, a lot of commercial products, for example. I've talked about that on Tuesday a bit. And when you apply engineering, when you got to apply guard load in conjunction with wind load, because there's a calculation where you put both of those loads together, NAFS would only calculate would test per wind load, your PG rating, and wouldn't determine the impact of a guard load at the same time that a wind load is occurring. So therefore, any window that is required to meet part 4 of the building code for guard load, therefore would not qualify as product covered under the scope of NAFS. Therefore, any non-Part 9 building, but then even the conversation we're having about Part 9 building, or anything below 900 meters now in a Part 9 building has to meet guard load. That actually means any window below 900 millimeters on any building, therefore NAFS is irrelevant.
And that's what, and I'm glad you brought that up because you're right in that any landing, for example, we get requests for this all the time where there's a window in a landing and it's, they're saying, well, the authority having jurisdiction notes it and says, well, you need engineering on it. And we're just checking it structurally. So there's this huge gray area and there's this huge disconnect of understanding what NAFS really covers and what it doesn't cover. And so we're going to kind of cover some of that a little bit this afternoon. But for other provinces, with this code clause in here, it's going to cause some definite friction.
So there's a whole lot going on there that needs to get sorted out before we get to 2025. Okay, so changes to the regulations on combustible products and non-combustible construction has opened up a new market for what we would consider typical residential products. So 314, combustible windows and doors and skylights. Clause 5 eases the restrictions on the use of combustible products by saying combustible window sashes and frames are permitted in buildings required to be of non-combustible construction, provided they are vertically non-contiguous between stories. So prior to this change, if you had combustible windows in a building, they needed at least 1 meter of separation between them. Now, those windows, in theory, could almost touch, and you would be okay. PVC products or fiberglass product or even wood products for that matter. So that is going to really open up a new market for those companies that were typically building combustible products, PVC, fiberglass, etc. So we're already seeing some of that going on. I know I was talking with, we went to the hockey game last night. That was really interesting. And I was sitting with Adrian from Innotech, and they're embracing this. and they're really going after these kinds of projects in British Columbia. So we're going to see more of that as we move forward. The change did not make it into the encapsulated mass timber construction section of the code. So right now, EMTC buildings would still require that meter separation. I did talk with the folks that did this work to make the change in the other parts of the code and simply admitted that they missed encapsulated mass timber at the time. They have put in a code change for it, but it is very unlikely it's going to make it through the 2025 cycle. So fall protection and egress. Language in the notes of the NBC caused a lot of confusion concerning what's known as an F2090 WOCD. These devices are compliant for egress and fall protection applications in the US and Quebec, and now Alberta, because they just changed. They just made an amendment. So there it is. So they just published a code amendment. They call it a stand data in Alberta that now allows these devices in Alberta for this application. They are not compliant for fall protection in BC or other provinces currently. So the egress language, and this is where it gets really sort of, you got to wrap your head around what it is they're trying to say. So openable from the inside without the use of keys, tools, or special knowledge. NBC, openable from the inside without the use. So same thing, right? So egress, you're all good. Fall protection language in BC can only be released with the use of tools or special knowledge. NBC can only be, so same language, right? F2090 WOCD. So F2090 is the standard that these devices are tested to. WOCD, window opening control device. In that document, it says release mechanisms to allow for emergency escape egress without the need for keys, tools, or special knowledge. And that right there is what makes these not compliant, right? So they're not compliant. Now, we had our commercial event on Tuesday in Surrey. It was really successful. We had over 120 people there. It was 5 great education sessions. It was really good. Okay, I'll plug that. So Assa Abloy was there, and they have one of these devices, and they're trying to get it compliant or accepted. But again, it's tested under the F2090 standard. And as soon as that happens, that language comes into play and makes this device non-compliant. So in my discussion with them, I said, well, why don't you take that device that you have tested and make a very, very small change to it and don't test it and say that it now doesn't fall under that language. They're thinking about it. So we'll see. I know that Adrian is working with them diligently to come up with something like that. Or the other question was, what does that mean? What is special knowledge? There is no definition in the building code. Nobody can tell me. I've asked building officials. I've asked the guys, at the higher up in the government, in the provinces. What is it? There is no definition for it. So could you have one of these devices, write a little explanation teaching a homeowner how these devices work, and now they have the special knowledge to operate? Good luck. So glass is guards. So every surface to which access is provided, including but not limited to flights of steps, ramps, exterior landings, porches, balconies, mezzanines, galleries, raised walkways, shall be protected by a guard. That's clause 1. Clause 7 in the same group, 9881, I think it is, in dwelling units over stairs, ramps, and landings. So what does that mean? Does that mean that if you're in a dwelling unit, you only need to have guard protection at stairs, ramps, and landings? Or does clause 1, which is the first clause in that group, does that cover everything? Well, I've posed that question to a number of different higher ups, BC Building Safety Standards. They are now like, oh, hang on a second, we need to look at this. So we've actually convened a small group that is going to be meeting with them on Wednesday, I think it is, to start diving into this to get some clarity, because interpretation of what those two clauses cover is everything when you're talking about guard glazing. So we'll see where it goes. But right now, the first response that I received from safety standards was that clause 1, it covers everything. So anyway, I don't know for sure. I don't have a clear answer. So we're going to sort it out. And once we get some clarity, we will we'll make sure that we get that out to everybody. Also posed it to the BC Building Officials Association for an interpretation, which they do. It can take a long time, but they are also aware and are looking at it to provide some clarity. So this is what we're faced with for guard glazing currently. So guard glazing is required. The window is below 900 millimeters from the floor. On the exterior, if you have a 600 millimeter drop from the floor level within 1200 millimeters of that opening, guard glazing is required. Same thing here, but it's just simply a 600 millimeter drop from the floor to the exterior. And then guard glazing is not required if the window is higher than 900 millimeters or it's less than 600 millimeter drop to the exterior. Same idea. So I'm saying the same thing. So we need to find some clarity on that because it can be very impactful. If you've got a lot of windows in a building that are below 900 millimeters in other areas than stairs, ramps, landings, you could be faced with, a significant amount of safety glass being required, and not necessarily just safety glass. You might be dealing with your engineer to make sure that that glass meets the guard impact loads. So the step code updated May 2023. So everybody in BC now needs to be on at least step 3, unless they pass a local bylaw that says that they can follow the prescriptive path. The only jurisdictions that I understand that are doing that are remote areas that don't have great access to people like energy advisors, lower door testing, etc. But for the most part, certainly everybody in the southern half of the province would currently be at least step 3. But District of West Vancouver and Part 9 is that step 4 with non-carbon fuel heating, appliances, fireplaces, etc. If they are using carbon fuel devices, then they actually have to meet step 5. So if you're selling into West Vancouver, be aware that it's not step 3. That just explains some of what that looks like, the different buildings, building types, and what the requirements are. West Vancouver actually has a great website for this stuff. They really get into it and explain what they're doing. So jump over to westvan.ca, I think it is, and you can sort it out, what you got to meet. And again, no matter what you're doing, always check with the local authority having jurisdiction, because you never know. A lot of these municipalities and cities, they do have good step code information on their websites, so go there. There's also a implementation updates website. Right now, it's kind of running out of date, I think, because they're saying, well, everybody's on at least step 3. So, but there are, like I say, with West Vancouver, if you go in there, it'll show you what cities, what jurisdictions are at what level, and give some explanation. So prescriptive path, if somebody's going that route, if they've passed the bylaw, you're 122 for windows, 184 for doors. And doors also have some leniencies based on heating zones. So off the top of my head, if you get into like zone 6, I think you can have 2 doors up to 2.6 or something like that. But all that information is in BC Building Code for you to look at. What's interesting about the door one in particular is that, okay, so they've got some leniency where you can use a door at 2.6 U value, but that's way above what the BC energy efficiency regulation will allow you. Not going to get into that one today because it's extremely frustrating conversation. 936 27D lays out what the values are. And again, you're looking at 1.22 across the board for prescriptive window U values. So rebate programs, the Greener Homes program ended, the federal rebate program ended February 12th. It ended about 3.5 years before they said that it would end. The funding was supposed to last 7 years. It lasted about 3 and a bit. It ended quite abruptly, and there was several manufacturers that were very, very unhappy about that because there was people in the queue that they were, getting quotes and that done and trying to sell jobs. And then all of a sudden the program ended like very, very abruptly. So a lot of unhappy people with that. The federal government has told us that they are bringing another program in. They said spring 2024. So we're waiting to see what that means. Early conversations was that it was going to be an income qualified program, which is similar to a program in BC, where you have to meet an income level to get the rebate. So we'll see what that looks like when we see it. Unfortunately, that's when we find out what it is when we see it, when you see it. BC Better Homes and the income qualified program are still in place. Federal program does not impact that. I don't know if people in the room are participating in the income qualified program, but it is very good. You sell $10,000 of windows to a homeowner, they pay you $500. The government sends you a check for $9,500. It's a great program, and there's a number of rebate window suppliers that are doing very well under that program. You do have to get into what's called the home performance contractor network, where you have to join into this program and you become listed as a preferred partner or whatever they call it to play in that game. It's very successful for a few of the guys that I know that are doing this. Like, it's really ramped up their business. And my understanding is there's no date at this point of them making changes or ending that program. So you can go to cleanbc.gov.bc.ca and you can find out all of the other rebates that are going on. There's a lot of jurisdictions that top up some of those as well. Like, I know Duncan, for example, adds an extra $50 to the window rebate, things like that. So good to look around if you're playing in that market. So the public review right now, this is always fun when you start talking about what dates we're looking at for standards and building codes, and that it can really blow your mind. So we just launched the BCBC 2024 based on the NBC 2020. And now they're working on changes to the NBC 2020 for the NBC 2025 that will apply to the BCBC 2027. That's what's going on. So there's a public review open right now for that, for the current proposed changes that apply to the NBC 2020. That ends April 29th. Anybody can go in and review and comment, and I strongly encourage you to do that. It's really well laid out. I think I bring it up here. It's a public review. You can go in. If you just simply go in and search National Building Code Public Review on Google, it'll give you the link to go to that site. And it's really well laid out, surprisingly, for a government operation. Broken down really well. It shows you what the code change requests are, gives you a description, and then you can go in and read all of the information about why they want to change it, what the reasons are, what clauses are impacted. It's a great site to go in and read all of this stuff when you got nothing to do. Like, I know Anton lays around reading the building code all day long, so he's probably in there reading this stuff. But it is great, and it impacts you. So for me, and the work that I do, I'll go in and read it, and I may think, okay, well, that's really not that big a deal, like whatever, because whatever. I might see it differently than you would see it and how your company may be impacted. So I really recommend that you go in and look at it and feel free to comment. It's a public review, so you can do that. Or feel free to shoot me a note and say, this is really messed up and you guys need to look at this and see what you can do to help us out. So strongly encourage you to do it, because there will be things that are going to change in the 2025 NBC that are going to impact the window door manufacturers. So that's the page. And like I say, it's really easy. National Building Code 2020, and then you can look at it by group, by provision. You open up that page and it's just a list of all the changes and what they mean. So highly encourage you to do that. So Energy Star 2024 participant agreement recently came out. It did not get to a lot of Energy Star participants because of people moved on, emails changed or whatever. So we did some work to try and make sure that at least our members were aware. And then in reading it, the deadline to approve that agreement was March 31st. So if you haven't done it, they'll actually kick you out of the program. If you do not accept and sign the participant agreement, you can be removed from the Energy Star program. So you might want to check with whoever's responsible for that in your organization, make sure it's been done. You can contact Jude Ellis at Enercan. He's the Energy Star Fenestration Manager, I think the term is that he uses. And he can help you through all of this stuff. He's very helpful, very responsive. He can answer your questions on many, many details within this. So the new thing that came out in this agreement that we had never seen before was the requirement to provide ship data. It's never been done under the Energy Star program in Canada. They do it in the US under the American Energy Star program. In the US, the two big window and door associations have set up a program with Energy Star US where manufacturers submit their data to either FGIA or WDMA, and then they submit. It's a very different environment, as I'm sure everybody's aware in the US. They're very cautious about sharing data and the privacy of that data. And for whatever reason, they opted to go that route. So we proposed that to Energy Star Canada once we saw what was going on here. And they simply said, no, we're not going to do that. They had already invested a lot of time into an online portal called YesCan, where you submit this data, and they had zero interest in entertaining any changes to that. So you have to submit ship data. What's that? It's actually, in this round, it's actually quite simple. You go in, you put in, you have a login that you get from them, you go into your account, and you put in how many units did I ship March 23 to March 24 that are covered under Energy Star. And then how many units did I ship that are not Energy Star? It's two numbers. It's not broken out by picture windows or doors or sliding doors, nothing. Very, very general total numbers is how they're starting this program. One of the questions that came out right away is, what's a unit? How do I count my units? You count by an Energy Star rated product. So you would count a picture window, a casement window, a sliding window, whatever that might be, based on, because that's how Energy Star does your listing. You don't count a 6-light casement fixed window as as one. You count it as 6. So there's 6 Energy Star products in that assembly. So that's how you count. They are saying, one more, they are saying that in the next year or 2 or 3, the data will become more detailed. You have to do deeper breakouts of what you ship.
Just to clarify that, Terry, this window over here would be how many units? 15 units. The top one, 15 units.
They actually had quite a blank stare on their face when we asked them, how do we count? So anyway, the YesCan portal, just if you haven't done this, you need to get on it, because like I say, they'll just simply remove you from the program. Reach out to Jude. He'll hook you up with getting your login and get it all squared away. They are good about, people that missed it or, were late. The other one that's been in the participant agreement for a while, but is getting more attention, is the verification testing. And this is another thing that they've been doing in the US for quite some time. So if you're in the Energy Star program, this detail is in your agreement that says they can get in touch with you and say, ship us Energy Star code, blah, 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 blah. Or not ship us, sorry. Energy Star code, whatever it is, that window needs to go to a lab for testing to verify that the performance is what is listed. That could get really tricky, really dicey, really quickly, because there's no, well, how much can I miss by? If I'm listed on the website at 1.4 and now I send it to a lab and it comes back at 1.45, what happens? Well, I don't know. They're not giving me any details on it. They are saying that they're going to be doing this. They have not been doing it. I was never asked for it over the years of my involvement. So just be aware, they can reach out to you and say, you need to test this product. No, you can send it to whoever you want to, as long as it's an accredited lab, right? Yep.
What would be the difference between a CSA certification program and an NFRC certification program where you would already have a validation unit?
Okay, so for anybody that doesn't know, if you're in the NFRC thermal certification program, you send a product to have it verified in the lab, physical testing. If you're in the CSA program, you don't actually do that. It's all done by computers. So Kyle asked, what if I'm in NFRC and I've already done the verification testing? Doesn't matter. You still have to retest the product. And I think what they're doing is they're trying to assure that whatever you're supplying matches what you have listed and that it's getting that same performance.
I'm going to quote Jeff Baker on this. A while ago, I remember him saying in the US, the Energy Star program there is if you fail that test, apparently there's a policy where you're obligated to go to every customer you've sold product to under the brand of Energy Star and tell them that the product does not perform as it was labeled. So I think this might be an attempt to kind of go in that direction.
Only in America. So yeah, I don't know where it'll go, but just be aware that it is in your participant agreement and you might get asked for verification of that product.
For products for the NFRC rated products where we're testing the gateway size and they choose a small picture window, will that affect them?
What would happen is they would say, okay, you need to test your slider window Energy Star listing number, and then you would build that exact same window. So yeah, you wouldn't be dealing with different sizes. No. So again, yes, you can go, there's videos, there's all kinds of stuff there that help you walk through what that means. All right, so that's it for me for now. Any other questions before I move over to Mr. Frank?
Maybe if you can comment, Terry, would there be slightly higher risk of a CSA certification that you don't have the ability to have that validation unit as opposed to NFRC where you're at least doing one?
It's a great question. So under NFRC, I go through thermal modeling with computer simulators, and then I test my window, and there's a percentage of allowance of what you need to do to qualify that product. Under CSA now, I've done all thermal modeling with computers and simulators. I've never tested that product. So now I go to the lab for verification testing, and I mean, we all know not all simulators are equal. So did the simulator make a mistake maybe? And now all of a sudden you're offside? It's a great question. And I don't know how they would deal with that. You would have a problem because your product's not performing as per your listing. So yeah, that's a great question. Okay, that's it. That's it for me then. Thanks, guys. And we're going to bring Murray up, and he's going to entertain us for the next hour or so.
Stop at an hour. No, I promise I'll go quick. I'm going to focus on part 9 stuff. It's my life. I want to back up and take a high level look at things a little bit more than I usually do. Because we're facing a ton of challenges when it comes to this new world order. The biggest question that has come to our attention in our facility as we test our way through all of this step code is what are we trying to achieve with the step code, and is it safe, and is it really giving us any advantage? And so I decided I'd go back a couple of years to 1730 and see what the heck happened back then, and see what we've actually done since 1730 with lightweight frame construction. And then ask ourselves the question, are we trying to cram something in 2 decades that might not even be safe? Or should we be looking ahead and just say, what about this net zero? What about passive house? Where is the target? Should we even be going there? A lot of these things are tough questions to address because we don't control them. There's so much political influence in them. There's so much misinformation out there that a lot of powerful groups are using to promote their methods and motives. So I thought I'd just get down to what are we going to have to do as we wade through, and not focus on that question of if we should, but how do we survive the next few years. And the first anomaly is BC is declaring that we're going to be all new houses to net zero by 2032. I don't know how that jives when we signed the reconciliation agreement for codes in Canada, and the code in Canada is working under a mandate where it declares that all new houses in Canada will be net zero for energy by 2030. So the first thing for me is this really a reconciliation? Are we all signed on? Yes, every province and territory is signed on. Are we supposed to be on one page? Yes, but then you get stand data abbreviations in Alberta, and you get BC standing on stuff. And I keep asking people, how is Vancouver building bylaw going to exist? Because in none of this harmonized code have I ever seen the opting out clause anymore. So are they even going to have a legal provision to have their own building code in there? There's a lot of really big umbrella issues, but I don't want to get too sidetracked by them. I dug back, and the first example of a lightweight frame construction project in residential in North America happened in the Prairie States. It happened, and they're not sure if it was 1730 or 31, but in any event, there's a picture of that actual facility. That is just a balloon framed house with hand framed trusses with a double top drag plate on there. Whether they knew that that was going to be necessary for earthquakes, or it was just something they decided they wanted to do. And the only thing that I can see that's substantially different between that is they do allow finger jointing of those long studs. And they call them 4x2s, not 2x4s. And back in those days, you had 6x2s and 8x2s and other things like that. So let's keep in mind that we're trying to take ostensibly a 300-year-old technology and make it net zero or beyond. So is there some lessons that we can learn in that? And the answer is, yeah, there's a ton of things we can do. We're working at modular cassettes so that we can address affordability and still allow freedom and exploration of architecture, and bring some more consistency and reduce the burden on skilled labor, because we just don't have enough to move forward with the kind of numbers of houses we have to build. And if we're going to rely on a traditional trades program, it's 8 years before those new entries are of value to this industry. We're done in 8 years if we don't get immediate response to things. So I think we're going to see a lot of other stuff that's going to contribute. And then I thought, well, how can I sort of sum this all together? Well, we're involved right now in replacing that nice demonstration net zero project that we built up in the Okanagan-Similkameen at the base of the provincial park there, Cathedral Lakes. Because it burned down in the forest fires in August. That was really disappointing for us, because we had humbly and in full disclosure attended to all of the wildland urban interface provisions of the federal government's program, and that burned down real good. and we've spent a fair amount of time talking to them about how stupid their program really was, like a 1-hour fire rating from inside to out. I asked them, are you really worried about the fire spread from inside your house going out during a forest fire? Or are we worried about, oh, maybe we should think about that? So an awful lot of lessons were learned in there, and we're trying to roll this in and ask the question, can we address affordability and architectural freedom and buildability and cost of ownership, which I consider quite different from affordability. Cost of ownership is If you can build a house that's twice as long-lived, then it has a much greater value to the homeowner than what we currently build, which under CSA S478, we build a house that's expected to last 50 to 99 years here in Canada. Really? So if I build a home for my wife today, and then I will that off to my daughter when I'm done with that house, and it's, you know, pushing 40 years into that longevity, what good is it for her? She's now got to find a place to live for 3 years or more, and the money to bridge that gap of 3 years to find a place to live with her then growing family so that she can tear down that house and rebuild on that lot and be exposed to the capital cost and construction of who knows what's going to be important at that point in time in new construction. So we're firmly of the opinion that no matter what we do, we got to get a little better than maybe what worked 300 years ago. And we got to work about improving durability and resiliency. You don't prevent forest fire damage. You don't prevent fire damage on a home. But what you can do is build layers of defense in there and construct it in a way so that you can peel back the damage till you get to good meat and then build it back out again. And that goes hand in hand with renewables. So why are we putting windows, especially if we're going to go further than 50 to 99 years? Let's just say we're going to try and get to 200 years. Is anybody comfortable right now putting a 200-year-old window technology into a new build? So we know that some things are going to turn over, mechanical choices and windows and all of these capital renewals, but you face that anyway as a homeowner. It doesn't affect the long-term cost of that home, as long as with well thought through design, and by that I mean embracing renewables and replacements in construction. Then maybe what we're doing is we're handing over houses that over 200 years just need a regular cycle of budget money. And then you can pass it on to your daughter, and she can pass it on to her daughter, and she can pass that on to her daughter. And let's just say for fun, what would happen if we got to 500 years? And it's ostensibly 15 generations. If 15 generations down my line, somebody complains about that bastard building a shitty house that only lasted 500 years, I'm okay with that, right? There's no such thing as permanent. How are we going to do that? Well, we got to get all this consumable lightweight stuff protected. And so a lot of you have heard me lecture. If I was to give you a piece of 2x4 right now, everybody in this room, on one condition, and that is that you store it under the bed you sleep in for the rest of your life. And if it isn't rotten, pass it on to somebody in your estate and give them the same instruction. How long till that 2x4 fails you? Forever? The environment we live in is a very comfortable and durable environment for major structure. So this whole idea about why do we stuff stuff into the inside of walls and all of that is because we've just sort of bumbled along on these old yurts, tents, if you will, that had no real accountability to energy. And, you know, for better or for worse, we've decided we need to do things to it. So let's follow along on some of that history and how it played out. Does this thing even want to work anymore? No, that's not what I wanted. So let's just skip ahead to the 1930s. A few things happened in there. We added platform into the framing. You can see on the left there. It's not really that important. This was a response to shorter sticks, faster erection. We needed shorter sticks because those big, long 24-foot 2x4s were getting cut from trees that had much greater value to the mill and to the forest industry than being cut into 24-foot 2x4s. So we saw this sort of movement to balloon frame and composites. We got to recognize that we started digging giant holes in the ground in the early 1900s, and we called them basements. But what was the purpose of that basement? Why did we start building those big holes? We did it because when you had those nice big houses, you had to put a big coal burning device in there to provide some thermal comfort with marginal or no insulation in there. And in order to have enough fuel to get you between deliveries, you had to have a place to store all that fuel. So those basements were primarily an invention to hold a bunch of fuel. And then somebody started realizing that if they threw old sandwich bags and sawdust down into a 2x4 frame wall, it seemed to get better. needed less fuel. So now part of the basement became a root cellar. And then they refined that art and they built bat-based products. And those bat-based or the blown, actually mineral fiber was the first blown insulating product that we had in there. With those refinements, they realized that they were actually getting even better energy performance and they had more basement, and then man caves were starting to be invented. The big question I have is, why do we keep building basements now? One of the things we're finding at net zero is you have to build conditioned attics. Night sky cooling and other things at true net zero energy performance don't work. You can't vent those spaces. So why not put your mechanical in there? And a lot of people say, well, because it won't fit. Well, we're not using the same size mechanical devices at net zero either. All of these things are maybe questions that haven't been asked. We've just responded to the next level. And the step code has really got us into that habit now. What do I need to marginally do to get me to that next step? So then all of a sudden we started recognizing in construction in Canada and in the States that when this insulation was in there and we finally got to this 2x4 level, we had to begin to consider what was the impact of that construction with respect to moisture, condensation, decay. And in 1948, we got our first codes here in Canada, and at the culmination of all of that research, if you check that code language in there, you needed a vapor barrier, and that's where they defined that 60 nanogram or 1 perm as a level. It's as arbitrary as the ventilation rates in attics. Nobody knows what the science is. Nobody even knows today if it's actually useful. There's a big question about if it is actually a practical level, but it started in 1948. And the other thing that I found really interesting in there is that was the invention of this thing called sheathing membrane as a requirement in building codes. So we started insulating, we started realizing that there was accountability, higher accountability to these lightweight frame buildings, that we were stuffing a bunch of stuff into the wall cavities and the attic cavities. And so when we realized that we were going to have to worry about vapor diffusion and we were going to have to at least maybe address air tightness, and a lot of people say, well, no, that wasn't in there. If you look at the first language in the sheathing membrane, it very clearly described it as a drape for the purpose of reducing the volume of air flowing through those walls. So the old black building paper was intended to be an air barrier. And the combination of that and a vapor or an asphalt impregnated paper on the inside of your insulation gave you the performance that you were looking for. It was basically an effective R level in the walls and comparable compensations for below grade and in your attics. But I like coming back to the walls because if we look at the effective insulation value of walls, it almost mirrors perfectly the advancement that we see in true energy performance improvements in houses between 1900 and where we are today. So yeah, our building code has always recognized the need from the very first day we had one here in Canada to control vapor diffusion when you're having insulated assembly, when you're separating an environment, and you must be concerned about the volume of air for the purpose of controlling that convective resultant deposit of water. Air flowing through and more moisture laden air finding cold surfaces in there. So a couple of things they did. They took an old 1919 home, which had a first example. This is in Saskatchewan. The University of Saskatchewan took this house apart in 1975 to see what a bunch of blown mineral fiber in there with sort of these early provisions. And because it was a blown mineral fiber, it basically was operating at about half the efficiency of a concerted dense blown or bat type product. And they didn't see any evidence of widespread moisture in that assembly. And now instead of asking ourselves why, we just kept saying if we need more energy efficiency, we just need more and better insulating materials in them. This is a graph that has haunted me for the last 4 or 5 years since I dug it out. It's a study. This is a very reputable study that was done out there. It was done in numbers that you have to make conversions before you start getting into a cold sweat. But what you're looking at here, if we convert it to today's speak, this is air changes per hour measured at 3, 2.5, 1.5, and 1. So what does this represent in terms of air tightness targets that we have right now? Step code from 2 to 5, right? Or tier code from 2 to 5. These two lines here, this one represents what happens when you got 48% relative humidity inside the building, and this one represents what happens when you have 36% relative humidity. And remember, under Part 9, we're only required to assure that we control that environment between 30 and 60. So these are conservatively dry and conservatively moist. There's definitely a wider range in there. And down here is 1 air change per hour, which is the target for net zero. And just for fun, I put 0.2 down here. So if you look at this graph and you look at this graph, they represent the kilograms of moisture deposited per square meter of structure internal to that wall per day. So 0.4 liters, 0.6 liters if you got 48% relative humidity inside, and you've got conformance with step 3, the new legal target here from last May. You're depositing 0.6 of a liter. Like that's a lot of water per square meter. If you do it in a percent wise, you'll see this also falls off very quickly when you get looser to 3. And it falls off back to numbers when we see this extrapolated in the databases that they use for all of this. It comes back down to this sub 0.1. So at the end of the day, if you're 6 and looser, you get about the same amount of deposition of moisture because there's so much heat flowing through that assembly, it's drying it out. And then it gets super risky in here. And then when you get back down to nice air tightness that we've proven now is pretty achievable. In fact, by 2030, all new homes have to hit that 1. We're tighter. It drops back down to that sort of predated. So let's put that and overlay that to leaky condo. And that creates some interesting things too. So what I want to do here is I want to just skip ahead for purpose of time here. This is a graph from 1890 to 2030. And on the left there is the effective R value of the walls. Again, a very good litmus of total energy performance. And along with that, there's a fairly consistent improvement in air tightness. When you're pre-1940 in Canada, the CMHC data shows that you were plus 12, as much as 16, depending on the region that you look in Canada, air changes per hour at 15. And you also see that the effective insulation of a wall, a 2x4 frame wall with absolutely nothing in it, is about 2, mostly made up of air films, a little bit with sheathing and some of the other materials. When you start putting sandwich bags in there, we've done it and we've run all kinds of metrics and tests on it, and it turns out that it goes from 2 to about effective 4, doubles. So what happened to the heat flow when you went from 2 to 4 in those days? From a hollow 2x4 wall to a drop in sawdust in it. We doubled the resistance, you half the energy flow from conduction. Now you still get convective flows and other things contributing to that, but in terms of the conduction loads in there, you cut it in half and all you had to do was throw sawdust in the walls. And then we saw it become a concerted effort to go to batt products and dense blown products. And in that generation, in the sort of 1910, 20, 30 era, when they patented fiberglass pink and all of those things, we basically got to an effective level of about 8, R8 in the walls. So we went from 2 to 4, and we went from 4 to 8. Again, doubled it, half that energy flow. And at that point in 8, in the 20s and 30s, is when those alarm bells started going off. We started seeing that the better job you did with insulation, the higher the interior relative humidity conditions, based somewhat in occupancy and somewhat in location in Canada, we started to see failure. And in those first version of our national code in 1948, we built in a requirement for vapor diffusion control and a curtain, an air curtain is what they were using for terms in there. But the first instinct or inklings of air tightness. And then we waited until we got to the 80s. And then what happened in the 1980s? Right around that era when all the 4-story wood frame condos were popping up like mushrooms all over British Columbia. We went from 2x4s to 2x6. Why? Did we need them structurally? Well, for 4-story, maybe for the first floor. But even that aside, why were we building all our houses out of 2x6s? In fact, in the code right now, does it tell you you must use 2x6s to build a house? It accommodates them. It accommodates 2x4s too. So what's the purpose of building a 2x6 wall in the late 70s and early 80s? Remember that our 2000 program was motivating us. There were lots of other things that were driving this. And when we went to that, what do we adjudicate the effective insulation value of those walls now? Well, it's a 2x6 wall, it's 15.6. We'll call it 16. So we went from 2 to 4, 4 to 8, and we started seeing signs that we needed to worry about vapor diffusion control and air tightness. We went from 8 to 16 and basically made a tighter bag and a less, we still had that one perm, but we were working down at, levels of 10 or 15 nanograms instead of 60 nanograms for vapor diffusion control. And we did a little bit better on air tightness, but in the lower mainland and the temperate rainforest, we were horrible compared to the rest of Canada. And everybody told me I was an idiot when I kept saying we're 6 or looser right through that whole leaky condo generation. And then when they finally studied it, yeah, it was 6 or looser. 6 to 8 was sort of the numbers, depending on where you were in British Columbia. But when you're in Saskatchewan, that was as low as 2 in average construction. So why do we get leaky condo? Well, we halved the conductive energy flow through that wall. We did a little bit about tightening up the airflow on there, and now it turned out those walls were insufficient for controlling the additional loads of wind-driven rain. In the past, they were all leaking. Go down and hang around Shaughnessy like I've done for the past 35 years, and go and take a ton of pictures if they'll let you when they start tearing them apart or substantially renovating them. Every one of those old Shaughnessy Tudor homes down there is a capillary broken rain screen wall. It's got vertical lath and then horizontal lath on the outside over top of building paper, and they knew what they were doing because they had that foundation keyed, and that paper dripped over the upper edge of that foundation at the bottom of that wall. And they did that because they didn't have welded wire lath. They were squishing stucco in between all of that horizontal lath, and it would just mushroom open in that cavity that had to be there for that mechanical lock to occur. And if you take them apart, you will find that it's full of 150 years worth of spider guts and spider webs, and every piece of wood in there has seen water for its entire life. Most of it was first growth Western red cedar, Douglas fir, pretty resistant species to decay, this natural drainage in the air circulation. And really, it was working as a capillary broken rain screen wall. It wasn't built that way, but they understood that the drainage made a lot of sense. And this was a pretty good idea because those Tudor mansions had what? All over interfaced into that stucco. Tudor boards, right? Horizontal and curved ones and all kinds of things. Well, what were they sealing that joint between stucco and those boards with? Remember, they hadn't invented sealants then. So they were just joints, just cold joints that terminated. And these things worked. They worked because of, in part, durability, in part that they weren't over insulated, in part that they had an accidental capillary broken rain screen assembly in there. But when we built condominiums, we just went because we needed to get this R16 effective. And I'm not saying that wasn't right, but what we didn't do is consider the impact of the additional loads of wind-driven rain getting into those assemblies and not enough latent energy in there to drive it back out before materials wetted up and decayed. So if you're looking for the one answer to what leaky condo was about our quest for energy and not paying attention to balancing our approach to all of these other things that need to be attended to. Well, if we kind of overlay some graphs on here we are with our step code, right? So there's your step code air tightness range. There's your generation of leaky condo. Was it okay for us to quadruple the amount of water that we're expecting to condense on the inside of that structure on top of the additional loads of wind-driven rain, on top of the reduction in enthalpy flowing through our building enclosure assemblies? It was a triple whammy that hurt us. And this is where the $17 billion in British Columbia is. Divide that out by how many British Columbians there are and figure out how much every man, woman, and child in BC is paid. So far, it's not done yet. And this is where we're headed. So is it going to be satisfactory to just build a fatter wall and put more insulation in it with the capillary break that we got on there? Or is that risky? And we're seeing a ton of examples now, the R22 requirements in the city of Vancouver. People are framing up with 2x8s. Why? Because that's the way we've always built. You know, we learned how to tilt this stuff up. You know, to get to true net zero effective R values in those walls, you got to get to 32. It's a pretty good number, and I'm going to prove it out here in the last bit of my presentation. But in order to get to 32, think about what you're doing from 1980 in the leaky condo. We went from 2 to 4, went to 4 to 8, and it was problematic. 2 to 4 made us recognize the need for vapor diffusion control in that. When we got to 8, we realized we needed to add a capillary break to that to improve the drying potential of that wall in another way other than cooking it out with enthalpy and providing drainage and all of the benefits of the detailing that came with that capillary break. We're going from 8 to 16 now. Now we're going to 32. And where are we right now with step 3? Where you're going 20% better than the same energy performance we were basically producing in 1980. You know, what kind of R value do you need to get to that? What kind of air tightness do you do? I mean, basically put an HRV in there and you're pretty close. And so what do you think builders are going to do? Do you think they're going to learn a new way to build air tightness, or do you think they're going to seal bags in those walls? You think they're just going to frame with a 2x8 and call her done? Look for cure in a can solutions, like some miracle thing where you just pay money and some contractor comes in and miraculously fills all these holes in your building envelope. Nobody knows how or where that stuff's going, but it's going in there. Because builders work on tight margins and they do what they know and they do what they do. And they're the only people in the whole industry that have to build 100% of a home. If you're a designer, you don't know how to design something, just don't design it. Leave it CFO, contractor figure out. If you're inspecting, who knows if you know everything that's on that building? You're not even accountable to inspecting 100% of the building. But can a builder build 94% of a house? And what's that missing 6 or 10 or 8% in knowledge and material and understanding? It's up to them to figure out how they're going to do it. And they don't work on giant margins right now. And so to get them to change their thinking about how you're going to put air tightness into an assembly, or how you're going to select windows, or what you're going to do mechanically. I mean, in the old days, you understood, you put fuel in and it burnt. And if you didn't want that combustion gas, you put it on a heat exchanger and you blew air over it and you took that heat and you put it around a building. Pretty easy to understand. Ask a builder to explain how a heat pump works. It's not crazy science, but it's very different from that. So I wanna really reinforce in here that on the other side of this, once you get past that 3 air change or the threshold at 3 air changes now, and you get back out into here into 6 and 8 and 9 or whatever, 5, all of this additional risk disappears again. And we know that. Buildings did fine till we got on the upside of that thing. And we know that when we build at net zero, all the examples that we're building right now, all of the long-term studies that we're doing on the example homes that are built with great ideals and great attention to detail and great methods that are a little different from what we did 300 years ago, we know we're having success on the other side of that. So one of the big fears I have is we're going through this period in here, and what new habits are we actually teaching the design and the builder community with this? We're not seeing people switching over to perfect wall and putting all the control layers on the outside. Go back to your 2x4 that I give you. If you keep that 2x4 under your bed, what happens if you frame your wall with it, but put all your control layers outside of that around your entire house? Now, it's the same as storing it under your bed, because the inside of your structural walls and your attic spaces are in the same conditioned environment that we strive to live in, 30 to 60% relative humidity, plus or minus 120 degrees C. So in doing that and getting out on the other side, that whole net zero thing, I don't think by any great magic was or thought or anything, but it accidentally is a really, really defendable number for us to get to. And at the end of the day, by 2028, you're going to have to be designing into net zero anyway. We're at 2024. We're only at step 3, 20% improvement. You got to get at least 4 times better than that to get to step 5 or tier 5 or net zero. So do we really want to fumble around in there? And of course, the answer is yeah, because that's the law and that's the code and that's the worst house you're allowed to build, described by the building code as it is right now. But my newest observations are, we haven't built one example. We've built a few examples at net zero with no compromise. We've just taken all of the lessons learned and questioned everything we do and taken a very balanced approach about putting the right mechanical systems and the right windows and the right amount of insulation and the right attention to detail with airtightness. And we've looked at fabrication methods that rely a little less on a high degree of skills, partly because we don't have a lot of experience with the skills that need to go there. So maybe modular, maybe component modular to keep the affordability thing under there. And if we package that all together, we're also figuring and proving it with Karen and my's money. And they burned to the ground, so we get to build them again. At least they were insured. But we can actually build them for the same money you're building 2x6 think fat infilled walls. We're getting to true net zero for the same money, actually less. And that's exciting because once the builder community starts picking up that they can build a better house for less money, are they going to be compelled to think about step 3 and step 4 and then eke their way forward? Or do they rip the Band-Aid off, create the skill sets right now, go to net zero, provide a better home with extended durability, lower overall cost of ownership, lower capital cost in construction, pretty much all the buzzwords that the politicians are looking for out there. And for us in our industry here in fenestration, we have a role to play in there too. What are the important factors that we have to consider in design and in installation when we're putting any kind of glazing surface into a building? Because there's going too far in some things, in everything we do in construction. You don't want to get everywhere on your windows. You don't want to get everywhere on your mechanical. You don't want to get everywhere on insulation. You don't want to get everywhere on airtightness. You want to get to that target zone of true net zero performance, roughly an 80% improvement or greater on energy use versus a reference house or the house that we're building traditionally before the step code. We want to be able to sort of encourage that very balanced approach of pushing a little bit on each one. And in order to do that, we need to know what tools do we have as designers and builders and building officials and manufacturers and suppliers and everybody else. What tools do we have that are going to answer and unweave this incredibly complex question? And what we've found now is we've already had the answer. It's been in our code for a few code cycles already. See, with all of this, the one thing that's happened, and we're finding in BC, they're just getting rid of prescriptive approaches, and there's a lot of pressure as we move towards net zero to really defend the tier code's commitment to that across Canada. And I don't want to argue right or wrong with that, but at the end of the day, in order to do a performance-based solution, you're going to have people do energy modeling. And that energy modeling currently has a community of energy advisors running software programs that put a bunch of these things, mechanical, and civil, and fenestration, and everything, airtightness, into a big machine, and it chug, 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 and it spits out numbers. And our building code allows for that, requires it if you're going performance-based, but it also requires something else that's been ignored horrifically for a long time, and that's the requirement that you have to also have a CSA F280 analysis done on a room-by-room heating and cooling load calculation on your building. And I want to keep this really simple. At the end of the day, what you get out of putting in all those parameters, what Hot 2000 will spit out for you, and other energy modeling softwares that are worried about your energy use, is they give you all the parameters so that this thing can chug through and do a calculation based on every little 1 hour increment for 365 days, based on 10 years worth of acquired bin data for the location you're building in. And at the end of each one of those calculations, it says I need to use this much energy for heating and or cooling. And if you're designing just for heating, eradicate the cooling. But what did we inherit on May the 8th of this year for BC for cooling? 1 or more room in every new home built now must have cooling, heat dome response. So what are you going to do? Put regular furnace in there and then put a little door or window rattler in there for one? Is that really an appropriate solution? Work, but is that an appropriate solution? Keep that in mind as we keep blasting through some of these relationships. The big difference between what an F280 does is it calculates the power, the maximum power that your heating and or cooling devices need to deal with the hottest day and the coldest day. So how do you size a furnace if you only know how much energy it uses over the year? You don't know anything about the hottie and the coldy days and everything else in there. You just know that I need 25 kilowatt hours of juice to heat this thing for this period of time. It doesn't tell you how big the furnace it needs to be. The power calculation, the room by room calculation, it tells you exactly how many BTU you need to effectively provide in heating and or cooling on a room by room basis and on a total building basis. Now you know how big that thing needs to be, how many BTU, how many tons, whatever reference you want to use for those mechanical devices. And then you still do an energy model calculation that gives you the energy total, because that's what we're using as a metric to say it's better than it was before. It's, you know, it is that 80% better or better than 80% than the reference house underneath there. I don't want to exclude that tool, but I want to have everybody in here seriously ask yourself the question, how often do you see an F280 done on any Part 9 project? It's a requirement under the building code. So if we do that, what do you know about solar heat gain and solar overheating on south-facing bedroom when you've completed your design and you put your window spec in there? You know exactly what that room will require on the hottest day to maintain cold and the impacts of the solar heat gain coefficient. And you can change it and rerun that F280, and it'll tell you what impact that has on the ultimate energy or power load that's going to be required to maintain comfort in that house. It'd be pretty handy too if you got to prove it for one room. How do you do that with Hot 2000? It doesn't break anything down into a room by room. The F280 does. And so is it available out there? Absolutely. TECA, HRAI nationally have just rewritten. They've got, as in November, they got their new release version out there, 5. It is a completely ground up, redone version, and it's been tested as the code requires under ASHRAE, what is it, 140 or the ASHRAE 140, proving that it does what it's supposed to do in accordance with what the expectations are in the building code. Interestingly, Hot 2000 doesn't. It has to by code, but it doesn't make the ASHRAE test. So if we're going to succeed moving forward, we got to understand that there's 2 design steps that cannot be ignored. Now, when you're dealing with a room like this, who deals with commercial, and you're dealing with Jomo and all of these incredible engineering minds out there, they're going to tell you you need to do your load calculations before you can effectively spec a window and fenestration package and something. But I admitted going in, I'm talking about the Part 9 experience here. Where is that process? It's required. It's desperately powerful. And if you get the right sized equipment in there, is that the end of your woes? Because what are you sizing the equipment for? The BTU required for heating, the BTU required for cooling. So let's say you don't need a whole bunch of cooling for that house, but you need a ton of heating because of the choices you made with air tightness and insulation and solar heat gain coefficients and everything else. So you got this really high demand heating load, and you want to do this with what? Nice mini split air source heat pump or a pancake installed heat pump system. Well, that heat pump just has a reversing valve in there. It either delivers cold or it delivers hot. And because of laws of physics, whatever BTU it can do this way is exactly the BTU that it can move in that direction. The only thing that's different is that under cooling, when you're bringing the air across there, you're subject to, particularly on the cooling side of the equation, you're subject to developing condensation. In developing condensation, you're taking airborne humidity and you're condensing it out. And so by lowering that phase, you have to release the energy that was put into that water to get it up into that higher phase. And so in the process of creating condensate in the chilling cycle in there, you're actually heating up the air that you're bringing across to cool. And you can't ignore those. So there's a couple of terms when you do an F280, you know, and they talk about sensible heat gain and sensible cooling loads and actuals, and they give you some parameters in there. Well, what we're finding in the step code is that in order to address these huge heating demands of these rather inefficient energy efficiency buildings in step 2 and 3 and 4, and then you add a little bit of cooling in there, the split on there is so great that you are 10 times oversized with that heat pump for the cooling demand load in that building. And what happens when you are way oversized on heating and cooling, what does it do to your mechanical system? It turns on, it's way overpowered. It almost instantly has an impact. Your thermostats go, whoa, whoa, and shut it off. And so it short cycles. And you basically put 10 years of on off on there in maybe 5 years or 3 years or 2 years. So finding that sweet spot where you got a balance, calculating in there the additional loss, if you will, that you have in cooling efficiency, means that there's going to be a point in there where you're right sizing the equipment as you get more and more energy efficient, and you're getting that split in there so that one piece of mechanical equipment is really happy to perform in there. And again, I don't know by thought or whatever, turns out that at true net zero, these graphs tighten up really nicely. You just naturally get it. And it makes more sense to put whole house cooling in there as opposed to just one room. 20 years ago, I used to lecture for BC Housing, then HPO, and we went all over BC with that education before it was mandatory. And I did Fort St. John, and I did Prince George, and every time I got into those zones 6, 7A for sure, 7B even with Fort Nelson, I kept telling them, you're going to be putting in heat pumps. And in Prince George, they laughed me out, said, not a chance. We're never going to put heat pumps in here. And then went in Global Homes, built a raffle house in Prince George 15, 18 years ago, and it had heat pump in it. And they were common in my lectures, and this is what they were going to promote. And it was put out for raffle tickets, and people toured it in the summer in downtown Prince George. And the number one comment that they got back was, wow, was that air conditioning ever nice? And now I'm told 65% of homes in Prince George going in have cooling. 15, 20 years ago, I was told you're an idiot. It'll never happen here. How many people here are old like me and remember when you grew up, your dad said, don't need no damn air conditioning in the car, it's Vancouver. How many cars didn't even have air conditioning in those days? Who here has air conditioning in your vehicle? Who would want to be without it? It's one of these things, once you get it. And there's other reasons. I mean, in a vehicle, having the air conditioner there allows you to, on a really rainy day, it allows you to dehumidify that cab by just recirculating the air. And I thought when I was a young building science guy, not putting 2 and 2 together, that when I bought this relatively new car, I thought the heating and cooling system was screwed on it because the air conditioner came on every time I put it on cab recirc and defrost. And then the penny dropped. Well, it's bringing in that huge moisture load from outside on a rainy spring or fall day where the temperature is pretty mild. And the first thing it did is it passed it over the air conditioner, and then it all just drops out of the bottom of that car. And then that dehumidified air then went over the heating block. They got to bleed heat off in those inefficient internal combustion engines anyway. So they just blew it over top of that. And as dry air, right, being heated and bringing that in, it was actually dehumidifying the cab because it was taking the moisture that was evaporating into the cab as I was warming it up and getting rid of it with the air conditioner and just going around and around and around. So that light going on was doing a really smart thing. Well, think about the opportunities we have for controlling our environment here. And then the last point, and then I want to do some graphs to sort of bear this out so you know that I'm not just pulling this out of air. The last point that I think we need to focus on here is when you sort of think about where they're pushing us now, what options do we have electric heating and cooling? And actually, Terry, you made a comment too. You're allowed to have a gas fireplace again, as long as you're not relying on it for principal heat. And you're allowed to have barbecues again. And you're allowed to have a bunch of things again. That's a whole nother seminar. They're sort of realizing now that if they harness methane from garbage sites and agriculture and forestry where it was otherwise going to go up in the environment, and then they liquefy it and they inject 1/28th of the volume of the natural gas lines in British Columbia with this recovered methane, the methane is 28 times more deleterious to our atmosphere by unit volume equivalents, carbon equivalents, than if you burn natural gas and you get CO2 release from there. So at 1/28th of our natural gas lines, if they were to convert it to biorecovered methane, then if you're burning natural gas, you're actually carbon neutral. What really makes it interesting is, what does Canada have a ton of? Agricultural, forest, and landmass, right? Second biggest country in the world. Who's another country that's huge that has all of those resources that are just rotting out there in the forests and in the agricultural lands and everything else? Russia. What would happen if the two of those countries got together and actually got serious about recovering all of that, liquefying it, tankering it across to China and everywhere else so that the cement industry greened and everything else greened? Things that make you go, You can actually buy those offsets right now from Fortis if you want. You can spend $5 a month more and buy the contributed fuel. You're not burning that BTU that went in there, but you're making a commitment to support the additional cost that they got, and they're exploring micro industries out there to develop all this. Ton of friction on that because the government hasn't figured out how to put an uncarbon tax on yet. So what are you going to do if you create a whole industry that makes Canada a net negative carbon country for another day, right? But it's important that we recognize that you can actually run heat pumps off of natural gas too. I don't want to vilify one fuel over another. I love me my solar. I love electricity. I love heat pump technologies. I love everything about it. We're using CO2 as a refrigerant in these things. I mean, this is just amazing. You know, they're not poking holes in ozone anymore and none of that stuff going on. And I'm not saying there's anything wrong with that technology. I mean, it's become so effective and so efficient with the advancements they've got in these environmentally accountable refrigerants that, you know, you kind of got to wonder why we wouldn't push in that direction. But if we're actually reducing the world's carbon footprint by gathering up all that methane out there and doing something productive with it, then maybe we've got another fuel source. Maybe. So here's the little house that we're building. It's 1,024 square feet. This is the first of the two buildings that we're going to replace the fire damage up at Ashnola. We are going to put a blog site up, but basically in the first week of June, this starts, and don't blink. I made a commitment that we will be done, move that bus, pillow mints, dressed and filmed in 99 days. Our builder, our design, everybody, all our supplier, all of our engineering, all of Eric's no sleep for the last 6 months of his life, because every time we think we got the design nailed, we start thinking again. And so we're way far down the path in our 10th generation attempt to getting to net zero and hammering all of those points that I made earlier here in the first half hour. And this is what we come up with. Now, I get it. This is a square footprint. If you want to dig in on this, you can have a look, but it's all based on cassettes. These cassettes are all easily built out of structural steel, lightweight steel infill, conventional lumber. We're using pretty much all Douglas fir #1 structural select because it is just way cheaper than playing around with engineered, and it's Part 9 conforming. All of these things fit into containers, so everything that gets shipped up to this site is going up in containers to prove that out, so that you've got component modular delivery, and then you swing all of these things into place. So I only have to teach one skill for the walls, for example, and that's how you join them structurally onto the platform they're on, and then how you develop and finalize the continuity with the air barrier and the second plane of protection and the insulation blanket on the outside. But you can teach that in about 3 days. And you could take somebody who has no construction experience and in 3 days turn them into somebody who could build 1,000 of these in any iteration that you want, because it comes down to one joint. Good. The muse for this was Brock Commons when RDH and Brian Hubbs and I were sitting around lamenting over the challenge of component modular, especially on the job out of Bella Bella for the nursing home rebuild, the nurses' living quarters. They had to send James up there, and James just went through 10 billion rolls of Sega tape trying to get the corners done and airtight. And if anybody's worked with James, you know it was airtight by the time it was done. But it was really difficult to get corners to come together in the field and component modular. At Brock Commons, and I'll admit, tempted by a little bit of scotch that night, we sort of said, why don't we send them out with the corners modular complete? And then every joint's the same joint all the way around. We'll take a look at the camera on time lapse of that. Just Google Brock Commons. And you'll see a nice video footage that shows the month of construction in there, and it goes so fast that there's never any hoarding on it. It's all mass timber. It's all engineered timber columns. It's all kinds of stuff that you wouldn't want to get wet. But each floor went up, what, 2 and 3 a week is how quick they built those 18. And the footprint of construction down below was nothing, because it was all being raised by a crane, and all the joints and completion was done from the inside. These panels went up, windows, insulation, air tightness, and everything assured, except for that joint that had to go in there. And by the time they got to the top, the roofing crew went in there and it rained on it. It snowed one night on that project, and they had no lasting staining or damage to any of those finishes in. So this is something we can explore. And for builders who are extremely good at framing and have those resources, that don't have it shipped component modular, just use the blueprints and put it together the way that it's designed and do it in the field. And we can streamline that process too in the design process. But it brings up a really interesting question. And that is, there's the floor plan, 2 bedrooms, king size beds, lots of room, single full bath, laundry room, mud room, change room for getting on the quads or the skidoos, big open kitchen with a peninsula, and then a beautiful open living area in there. It's going to have a little wood stove that burns 9-inch sticks maximum, because it's the smallest stove I can find, and it still will overheat that house at -24, the design temperature for that building. We ran the 280, we optimized the windows and the air tightness and the insulation package, and basically that's R32 walls, all 42 or R4 and 32 underneath. It's R42 effective on the roof. Air tightness on this will be Tyvek. It's going to be GPS foam insulation. So it's 6 inches underneath and on the walls and 8 inches on the roof. Its installation has some specialty fasteners that we've sort of worked with and perfected here that allow all that to go on in the field or ship as partially completed. And then it's just Douglas fir borate treated stripping on the outside. And then we're using a precast stow stucco in a box, if you will. It's a recovered glass, recycled glass pellet aggregate concrete product, and we're 4 months ahead of the German certification, but they are now using all the binders in it are going to be rated for fire resiliency. So it'll be a 45-minute rated board in the future. I still want to put this stuff on. And then over top of that, as a warranted stow system, I'm putting on the stow's base coat with its reinforcement and creating basically the equivalent to your old scratch coat. And then instead of the traditional EIFS acrylic finishes on the outside, we're using a sprayed cork finish. And it's recognized stow warranted assembly using a pretty interesting product there. And one of the reasons I wanted to go into the cork is because it chars and becomes quite resistant to fire. In there, we're also going to put a fabric of a charring material that's being used now around telephone poles that constantly burn whenever they're in a grass fire or in a forest fire. Now they're wrapping these poles with this blanket, and it chars and provides as much as 183-hour fire resiliency at over 2,000 Fahrenheit. A forest fire that burned my place down was hot. It melted all the aluminum engine blocks, everything. But by the metallurgy that we pulled out of there, pretty convinced that it never spiked above 2,000 or 2,100 Fahrenheit. And then windows, they last 25 minutes. Forest fires last longer than that. And we had beautiful fiberglass triple, all tempered and lammy on the outside, but everything that made the urban wildfire interface legit. And the only thing that was left was all the tiny little pea shards of the glass and the fiberglass fibers. There's nothing else left there. But that house burned from the inside out, and it burned for 8 days. They never put a bucket of water on that fire. It was crazy intensity. The winds up there, and we had pretty good knowledge of what went on there because we had cameras and we had a Starlink system. So until that all burned up too, we knew exactly how it approached and what the mechanisms were and what the heats were and what the winds were. When you can take a Douglas fir with a 20-inch base and bend it over 45 degrees, that's a breeze. Right? So we're building this with improved resiliency, and the next one, which will be phase 2, which will be the beautiful heavy timber, the mimic of the one that we built before with lessons learned. We're going to push that one right to the edge, and we're going to put fire and smoke curtains on the inside of all of those windows, because we also learned from other of my neighbors up in that neighborhood who had steel shutters fully sealed over all of their windows. They got up there and they went, ah, everything's beautiful. My place didn't burn. And then they went inside and all their windows were completely cooked out and all kinds of damage inside because it was 2,000 degrees Fahrenheit outside the cabin for enough period of a time. So this is the Muse. This is actually replacing a trailer that we had parked up there. And my wife and I are done with hauling trailers around. So we're calling this the bunkhouse. And this is going to be the replacement for that structure. So we're starting in June, first week. And take a look on our website. I'm going to have a little thing on there. Anybody, everybody, welcome to come up. When we built the first demonstration one up there 3 years ago and 2 years ago, we invited every authority having jurisdiction that we could convince to come out. And by the time we were getting near completion, they were coming in busloads from everywhere because they didn't have to make a decision if it made code or not. They had an opportunity to see what we were doing and discuss their concerns, and we were able to convey with them why we believe this interpreted well, and overlaid that with all kinds of other stuff, lateral load provisions and urban wildland interface conditions and supply of water, which is not very well understood by the people in charge of water in this province out there. So, and I'll show, and the F280 on this basically came up that we need, what's this one, 18,000 BTU or 12,000? 12,000 BTU. 12,000 BTU is the peak that we need for heating and cooling. So 12,000 BTU. So we're going to put 18,000 capacity in here. You don't want to burn things at the edge of their capacity. Cold weather, because we have a fairly big spread in that part of the world. We're adjacent to the desert, so the cold is very cold and the hot is very hot, and it happens often. So we don't want supplemental heat in there. And then working with all the heat pump suppliers, Mitsu is who we're settled on for this one, but there's tons of really responsible groups out there. We're going to have one cassette only in the entire house. Mini split, one head. Huge COPs, 3.9. 18,000 BTU, it'll comfortably hum at 12,000. It'll produce all the heating, all the cooling we need. Adjusted the window spec for solar. It's such a low percentage of glazing on this that solar heat gain was really not a thing, but I'll even show you the impact of rotating this northeast, south, and west. And then at the end of the day, the big question is, how the heck are you going to get that thermal comfort to all those rooms? It's a legit question. You know, and honestly, nowadays you got such huge demands like 40, 50, 60, 70,000 BTU for your thermal comfort. You just put a head in every room, you know, the ones that you're worried about anyway. But this one here, I couldn't find small enough heads. Honestly, you could put a tray of ice cubes in each one of these things on a hot day and it would do a pretty good job. So then we said, what we're doing is we're microsizing the mechanical demand on heating and cooling. And these are becoming very small units and they're becoming very inexpensive. And there's just no reason to duct them anymore. 6, 8-inch big plenum systems. It's expensive. Leave a HVAC guy alone with a Sawzall and put a Paralam beam in there and you know what's happening to it, right? This avoids that. It's 2 3/8-inch soft copper runs, one of them coming from outside to in. The entire mechanical installation from front to back on the heating and cooling side is 1/20th of the cost of ducting and supplying your furnace. But what's happened, and I guess it was obvious, I just never really thought about it much until the last few years, is under 932 in Part 9, you have a ventilation requirement, and that's based on human safety and comfort. And it's preset based on occupancy of that building and a couple other parameters. So does the ventilation system change? No. All my walls don't have insulation or anything in them, and I've gone back structurally to 2x4. Turns out that you can get like Zentner units, amazing technologies, manifold, infinitely balanceable, and they run off a 3 1/8-inch flex hose. And they don't have the same mechanical resistance because they run at a slightly higher pressure. So it's not like the old 9 feet of mechanical resistance for an elbow and all that. You can run tremendous runs of 3 1/8, and if you run them from a plenum and distribution, so you got a box on the side of your HRV, your heat recovery unit, and then you've got one pipe for each one of your supply and return elements coming back into that manifold. And you just run them and drop them or bring them up through that 2x4 wall and put high side returns and put your ventilation supply and return throughout that house and move the air. Now, this is a shortcoming in the code, and I see no change anywhere in the future, although I just threw my hat in this week I'm on for the 2030 code cycle. So there goes another bunch of months of my life for no money, but it's fun. I love that stuff. So the green ones represent the return lines, and the blue ones are the supply lines. So I'm going to supply air, or the blue ones are my return, and the green ones are my supply. So I'm going to supply air into that main room, and I'm going to have this tremendous thermal control and ventilation that I can balance out beautifully. And if I need 2 heads, I'll run 2 in there. Now I got to get that thermal energy into all the other rooms that are in here. And you'll notice I've got a supply over top of that mudroom. So how am I going to get air to flow into those bathrooms and the bathroom and those bedrooms? Because if I could, it'd be a huge undercut. And then you're getting all the stuff that's at the bottom that's pretty stratified. Or I could put a big 12-inch by 12-inch grill through the door. Of course, that'd be fun in your bedrooms to have a grill 12-inch by 12-inch out into the main room. So we were talking to this manufacturing group, young guys out in Burnaby, can't keep up with their orders. A couple of engineers did a master's thesis on doors. These are interior doors, and they have this beautiful little slit on that side and the equivalent on the inside, but on the other end of that door. And you can order these with just standard builder special primer and paint them out. I'm ordering these with a nice wood veneer and working them into the finishes of the cabin. And the equivalent ventilation area of that door is 12 by 12 square inches. And it's uniform top to bottom over the height of that door. And the STC on that's 24. It's better than a solid core door with swept closures. So no undercutting. You're basically maintaining an STC 24 with a door like that. So I ordered 3 of them. We're going to put one on the bathroom and one on each of the bedrooms. And I'm only going to draw air out of those spaces, and I'm putting that return of the HRV system over the windows. So now I'm cycling everything into that room, and then I'm returning it past the windows to maintain thermal equality across those fenestrated surfaces in there. It all goes back. I get this magnificent heat exchange. And what's really interesting is I got water reuse provisions in here. We got a sewage plant because we're way off grid and everything else. All the stuff that produces heat, solar battery charging and inversion, we're doing that all in an exterior shack that confines all of that, super insulated. And we're recovering that heat energy and putting it into the water reuse that runs all of the toilets and the laundry in there. And then we've got a geo loop off of the HRV that dips into that 2,000 liters worth of water reuse that's got all the enthalpy that I've collected from inefficient generators and all that stuff. And 30% of my heating load has actually been taken care of by the HRV. And it got me even closer into the perfect balance between heating and cooling. So let's wind up here really quickly. What does this look like when you run F280s? So I'll just do it on this. We've done this for tons of archetypes. We've done it for every zone up to 7B. But here's the effect of that cabin in that location of north, east, south, or west facing. And by that, I'm talking about the main glazed, big doors, big room facing down to the river on the south elevation. So you can see in here, based on the window spec that we got on this project, we're only really got a variance of about 1,000 BTU. Mind you, we only got about a net 12,000 BTU heating and cooling load on this thing. So which way do you want to look at it? 8%? It's not insignificant, but it's also single story. It's got natural overhangs. It has a low glazing percentage on there. The point is, I actually down-spec'd from the first cabin that we built up there on the window spec because it wasn't my next best dollar to go to the absolute bitter cutting edge. This is a very good triple glazed window, but it isn't the 366 craziness that we had on the previous set of windows, but that was a much higher, and it's got a wall of glass that's facing south all the time. So then we take a look at some of the other relationships. This is your ceiling. And remember, the ceiling in perfect wall assembly is your roof assembly, structure under, and everything's PMR, inverted over top, right? So membrane insulation, capillary broken drainage provision, and a roofing material over top of that. So your ceiling is roughly your attic, I guess, in the old days, right? And this is your heating load calculation, 16,000 down to 12,000 based on down here, your R values. So there's 15.6, that's where we are today. And well, that's for walls. Whatever you're in roofs, somewhere in this range in here, that would be your line. We're building our roofs out at about effective 42. So we're in here. But you'll notice that the split in here is pretty consistent all the way through, about 2,500 BTU. So of itself, I really don't care about the offset of the cooling system being less efficient because of condensate, and I'm not tempted to put in an ERV instead of an HRV to deal with that, but there's losses involved with going to an ERV over an HRV. It wouldn't make any sense in here because you're basically in about a sweet spot no matter where you are. But that didn't hold true for other elements. This is your floor. And remember, I'm elevated on screw piles, so I'm completely exposed underneath because I don't want a crawl space, and I don't want a basement, and I don't want radon gas, and I don't want any of that stuff, and I don't need it because I don't need it to put my mechanical stuff anymore. And I certainly don't need a season's worth of coal in there, and I don't need a big coal-fired furnace down in that space. So I said, no, I'll build it as a loft and a catwalk and all kinds of cool architecture up top. And I'll use that loft area on the backside as a mechanical room, fully conditioned, and Bob's your own. So this starts to point out that in the old days with a heat pump, this reach here is huge, pushing 4,000 BTU. So you're going to have to oversize your heat pump to get your heating requirement in that installation. And you're going to have a way oversized cooling condition if you go to a mini split or a single source heating and cooling. But by pushing those walls out to 32, we get right about perfectly into the sweet spot for that. It's well within the requirements for top bottom headroom in the code. It's certainly within the requirements of the top bottom headroom that we have from the reality, because we know what the living conditions in, and we've had weather stations up there for years. We know what living conditions are inside and out net in occupied space and exactly that lot. And then you'll notice that the advantage from that standpoint, right sizing your mechanical, doesn't get that much better. Even if you double your insulation, you're only getting maybe 10, 15% better on that split. So this is the new language. Where's my next best dollar? And where have I hit the point of diminishing returns, not only in money, but in right sizing equipment and longevity of that equipment as a result of having that choice balance, et cetera, et cetera. And this curve on walls and floors doesn't seem to matter where we go. The worst possible place for heat pumps is in the step code here. So if you haven't figured it out, I'm not a big fan of the step code. Do it, right? Whatever. I just think it's tremendously inefficient and doesn't teach us any good lessons or anything. But the fact that we can build this stuff cheaper because we're optimizing everything, not the least of which is that if you take the basement out of there, you got over $200,000 on a $500,000 build to offset any of the additional costs of your performance materials that you're going to need in everything else. This will be built, I swear to God, this will be built at 300 to 300. What do you say now, Eric? 300 to 330? What are you going on record with? Okay, if it's more than 330, you have to pay the bills. A square foot. But remember, this is 1,024 square feet, but we got a 500 square foot mezzanine that's a mechanical room and a reading nook and a catwalk, and and there's the BS of Teddies and Mueys. They divide your metrics by square meters of floor area. Like if you took a 2-story house and you took those 2 floors and divided that by the energy or the mechanical requirement and got a metric, X amount of gigajoules per square meter of floor. And then you just took the second floor out, the exact same envelope, everything. What would be the change in the energy consumption of that house, with or without that second floor? Nothing. Where's the energy flow? Through the envelope. So why are these metrics penalizing you for great rooms or any kind of tall ceilings? They're all artificially making it unavailable when you're using Hot 2000 to get anywhere. Hot 2000 doesn't respond to cooling. So many of your energy advisors are just simply cheating off the solar heat gain, saying, forget it, don't want any. It reduces their heating load on their calculations, and Bob's your uncle. And then you can't live in that house in the summer. Well, if physics would tell you that a heat pump would run to itself, except it doesn't, because on the cooling cycle it screws you by recovering energy from the phase change of the condensate. So I'm there, Terry. I'm there.
So just to repeat that, like the high heat gain concept, when if your cooling load is less than your heating load for sizing.
Yeah.
Theory, higher heat gain windows would bring those two load calculations to this more about, like, it would increase your cooling load, but it would reduce your heating load.
Right, but if you get too close in there, name an HRV that doesn't form condensate at least part of its life. So now what you got to do is you got to decide, well, do I put an ERV in there and scrub the majority of that latent moisture out of that air before it gets into the temperature exchange, so I reduce the condensate load? But now you got a less efficient device that's using more energy to be less efficient. And you got more mechanicals. You got a little squirrel cage or something running with a desiccant, and it's pulling the moisture before it goes through or you get a good old HRV. I mean, think about it. It's a bunch of coroplasts with the lines this way and this way. And all the air going out goes through the ones in this direction. All the air coming in goes in that direction. And that interfered massive surface contact of those two flows of air is what gives you 60, 70, 80, as much as 85% energy recovery. But if it's forming condensation in there, it's heating everything up. And that's not helping you on the cooling, because you're bringing air inside, and then the condensate actually defeats the cooling or adds to your cooling load. So my fear is that this gets a little beyond an hour lecture, but pull back. The truth is, we know all this stuff about HRV. TECA and the mechanical industry know how to do this stuff. And we have machines that do this stuff for us and do it very well. And they're well supplied. And we have a trade that's recognized here in British Columbia that installs and maintains these things and knows how to play with the refrigerants and can deal with CO2 and all of that kind of stuff. So you have all of that. And so as expert as the fenestration industry is in it, you go to a mechanical tech who's tuning up heat pumps all day and ask them to describe an IGU and its performance. The structural accountability of a frame with safety glass and railings because of a drop in elevation on the end, like they're just going to glaze over. And so where do you think the builder is? And where do you think the home designers are? By the way, where are the home designers? You never see them in our education. They're just drawing pretty pictures, and all of this stuff has to be thought into it. And this is the new world, because we can do this, and it's a real simple tool, the 280. We started brainstorming this week. We're going to put a little toggle system together so that you just input data and then you what if it. Well, if I push here, what does it do? How does it affect everything else? Well, it's not pushing anything. It's just costing me more money. I'm spinning my wheels. How about if I put $10 here? How about if I put $10 here? And then as a design tool, you don't even have to understand it. It's going to right size all your stuff with the idea that you got to deliver on a tier 5 or a step 5 deliverable. But there's too many things standing in my way for me to give you that efficiency at step 3 or step 4. It's just barbaric continuation of 300-year-old technology. And again, I don't think it's because somebody in Ottawa was so prophetic that they had all this figured out and decided net zero was where we got to go. Matter of fact, they admit openly that they thought net zero meant that there wouldn't be carbon problems anymore. And then I pointed out, well, I can give you a pretty carbon ugly building at net zero for energy, right? So yeah, and now what do we got? Now we got a carbon net zero code too. if you make a building last 500 years, do you care about embodied carbon? Just think you go, They don't know how to account for it. But you do, and you're only using 60 years to light it out. Solar heat gain on cooling. Linear relationship, which just tells you that it's a linear relationship in the F280, but that F280 has been under some pretty heavy scrutiny. So basically what they're saying is that here's your range of air changes per hour, and then all stacked on top of each other here. So that return in here is not affected by air tightness. So what we do is we try and find something that is unaffected by everything else. If it's affected by a second issue, then we run 2 graphs and we do a comparison on those in 3D. But a lot of these relationships, when you get down to them, it just turns out there's a hell of a lot of BTU on the table by just ranging, your solar heat gain coefficient from 0.2 to 0.8. 7,000 BTU on that house, which is only 12,000 BTU. Make a lot of sense. Take a look. So we ended up in around here on our window spec because we could justify it. It's a really, really good window. So, any questions? Scared? Yeah, I love it. Have you got a mic with you? Yeah.
For buildings older than 1980 in renovation, common, let's replace all the windows, right? So thing to do component, like when you're doing specific scope component replacement, first call you get after you do that, you take the old single pane non-thermally broken aluminum windows out of a 1970s 3-story walk up at Kitsilano. First call you get in a cold winter day is I have condensation.
Yeah.
Because you've taken out a condenser.
Yeah.
What are the problems? Like the Vancouver building bylaw in theory requires you to bring windows in Part 10 up to current code for energy. There's some caveats in there. But are we introducing potential envelope issues by spiking humidity inside homes that don't have ventilation ability? And what is the consequence and what's the awareness of, like, are we seeing that problem? And I'm just curious to know what your thoughts are on that one.
Yeah, unintended consequences. I mean, it just goes back to the whole concept of my conversation here. We didn't put anything in the 2x4 walls. And then one day somebody swept up junk and threw it in the walls and noted that it had an impact on energy. I thought, well, now I don't have to take this to the dump and it's a better energy performer. If you had to do it again, you're building science. You did your time out there with Martin and that at BCIT. If you had to do it again and you had a blank piece of paper and the only kind of construction we had was yurts at this point, would you go, I'm going to build the structure out of lightweight, highly sensitive materials and I'm going to put the entire thermal gradient across that structure? Nope. So to answer your question, to go in there and just spec the hell out of a window, you're going to get a noticeable change in performance because the windows have the USI, or the U value on windows is always a strong contributor to what your overall UA above ground is, and that has a real deliverable effect. But to your other point, you've changed that fine line of how that home used to work, and you've now changed all of the hydrothermal performance and all of the air circulation, which is uncoated and not even thought about. And then on top of that, how are they installing those windows? Are they relying on the fact that it was put in there really bad in the past and it didn't rot all the window openings out from the unique combination of overhangs on that particular site? So they look left, look right. Well, worked for 25 years. I'll put this window in too, right? So you're not really encouraging any kind of significant improvements in anything else. But by changing one thing, what happens? It's like getting acupuncture. I got a headache, so they stick a needle in your big toe. But that's the buzzword, unintended consequences. I mean, in the 1980s, we wanted better energy. They had the R2000 program. They figured out how to build walls and put more pink stuff in it. And they went ahead, and then what they didn't realize is they got to the edge of where that wrong built technology, that 300-year-old technology, could handle it. So yeah, does that make sense? Does it make sense to rehabilitate and force a massive, or should there be a reasonable attempt to do a power calculation and combine that with an energy use evaluation? So your hot 2000, your F280, like you do on new houses, and then run through simple analysis like this. What happens if I do push this window? And it'll throw itself up in these relationships really quickly. But the one pet peeve here is nothing deals with circulation. That whole business of those doors and me using the HVAC system to move that thermal comfort around with my ventilation system, there isn't even a provision to deal with circulation in Part 9. And I'm using an advanced and using new innovation to get me there. So if you're going to do it, have incentives for doing it, but then have requirements, and then we got to do a better job about training our energy advisors too. Because they're coming in and say, do this, and then you explain to them, well, that's not quite the whole picture. So,
All right, Murray.
Yep.
You've run long, which is really surprising to me.
I ran exactly 1 hour.
I do have a question though that you were talking about your first build, and the fire started from inside.
Yeah.
Just quickly give us like what happened there.
Well, every one of the propane cylinders on the 19 properties that all of our neighbors had became flamethrowers because that burst manifold on all new propane tanks released the pressure before the tanks exploded. But my 77-year-old neighbor, who squirrels any kind of scrounge he can get, had a very old propane cylinder on the front of his fifth wheel. And he wouldn't listen to me, and he kept encroaching on the property line with his, and I said, it's supposed to be a setback here. Great guy. Anyway, half of his propane tank was scrambled around just the frame rails of his trailer, because that's all that was left. And the other half was in the rubble beside our big picture window on the side facing his trailer.
Okay, so the fire started inside, but it was a missile from outside.
It was a missile from outside.
Gotcha.
Yeah.
Okay.
Yeah.
Noticed that.
And just one before we do lunch, was there any requirement for the windows being in a wildfire interurban interface, or is that region maybe like I'm looking for? Was there a requirement for the windows to meet any kind of fire rating?
No, as long as they're subject to the same exclusion for commercial and non-combustible. So fiberglass, wood,
Yeah.
all of them are fine for use in there. Doesn't make it right.
Yeah.
Thing is, you're not going to bet. We've experimented with some of the IGUs that have 120-minute ratings on them. Well, first of all, it's like looking through a 1960s Coke bottle,
Yeah.
right? And that's before it goes. Then when it goes, it gels, and then there's nothing left of it. And we found out a lot of interesting things. We had bundles of comfort board IS Rockwool. Beautiful. We flew over in a helicopter because we couldn't get into the valley, and I had to do the rapid assessment of all the damage up there. That was fun. And we got pictures of all those bundles, and I'm going, there it is. You know, Rockwool's got a real good advertising campaign here. Bundle with everything burned around it, the shed it was in, the house that was over it. And then when we got there to do the cleanup, you pick it up and it just turns to dust. So the point is that any different than type 1 EPS or GPS foam? They char. They only burn in the presence of a direct flame. Direct flames don't have enough fuel capacity to get through 6 or 8 inches of that stuff. So at the end of the day, you got to replace the GPS or you got to replace the Rockwool. Neither survives. Your window won't survive. So our entire thinking now is onions. Got to be consumable layers that are easily back to and then built back out from, and protect the structure and protect the integrity of the air tightness. Because in the event, well, there's two things that piss me off there, but in the event of the next one, we're going to put the smoke and flame curtains in that are in a sealed cassette, and they'll be inside the windows. People say, why don't you put them on the outside? Why? I got to replace the windows anyway. They're not going to survive that. The curtain will, but the window won't, and behind it. So let the window burn. Now I got those curtains. I don't have any smoke, and I've got no airflow to allow embers to fly in. And that's what causes so much of the fire risk, is these burning conifer balls of napalm. And they'll, you know, where they hit burns 3 lots in a row. Where they missed, because we have a river and a Forest Service road, it went around. My one neighbor 6 down had a 5-gallon jug of gas beside his generator. His windows were open and he'd run into town to get stuff. And he got back, nothing. Nothing burnt. Not even a singe on it. He'd put burnt sawdust down on all his driveways so he didn't get dust on there. It's just, no. So there, it doesn't make sense, and it is that. But you have to, yeah, you'll never stop it. The big thing, you know, what pissed me off about that is we had a active fire suppression system with forest fire rated sprinkler heads that had enough water flow to take the enthalpy of 2100 degrees and drop it to 900. And at 900, everything in my place would have survived. But the day before we got written notice from Natural Resources BC, you got to get those intakes out of the river, which turns out to be not true. Any resident in BC has unfettered access to surface water at any time for the purpose of fire suppression, as long as you don't pump it out and store it indefinitely. So it actually tells you to put pickups in the river instead of pumping 50,000 liters into a bladder tank buried underground or something, because now you're diverting water, right? And that you need a license for. So yeah, the day before, and we could have turned it on by remote control through our systems, but I would have just burned the pumps out. So we had 4 inches, two 2-inch lines, and we could have easily curtained that whole site up there. Biggest disappointment for me is we would have known if that works or not. Right? And I'm not donating another $1 million worth of real estate to experiment number 2. Somebody else can go burn their stuff down for it, right?
All right, Murray, thank you very much. That was a lot of information. So kudos to them. We've got Kyle, of course, and David Vadocz from RDH. So we're going to walk through that relationship and engineering NAFS products. And I really would love to see this to be interactive. So feel free to stop us anywhere in this discussion if you have questions or you want to talk about a particular item that they're talking about. Just put your hand up. I'll run over and we'll get you into the conversation. All right, let's go. So we're going to talk about the request, the initial review for compliance, information for submitting. That's submitting from Westeck to RDH, the engineering review. So that's the work done over at RDH, the back and forth conversation that they have, which often can be complicated and challenging, and a lot of back and forth. The documentation for getting that product to where it needs to get to, and then building it. I mean, it's all fine and good to get the work done, get the paperwork and then the drawings and whatever the requirements are. But then you got to figure out, well, how's the floor going to deal with this? And then the documentation of that product when it goes to the job. Slide. Okay, so the request. It's not possible to test every product and design out there that falls under NAFS. So Kyle, I'm going to let you just walk through what that looks like.
So is it possible? No. I think, are there any manufacturers here? Would you concur?
Not possible.
Somewhat?
That's the first answer that comes out of the technical department's mouth. Possible to build it? No. All right.
Not possible to do all designs and test all designs. So perhaps what are some reasons why it would not be possible to test all designs? Configurations, sizes, mold assemblies, money. Thanks, Doug. Different product assemblies, swing doors to windows, windows to patio doors, etc. Also, to test configurations and assemblies with the thought of supplying somebody's dream home with products. You're essentially trying to anticipate designers or architects or the end user, the homeowner's thoughts of what their window configuration should be. It's just simply not possible.
So customers unwilling to change?
Your slide.
Are we? Sorry, can we go back one? Sorry about that. Okay, yeah. Go ahead.
So where do these requests come from? Primarily our customers, builders, homeowners, walk-ins into the showrooms. Secondarily from architects and designers, project consultants, or specification writers. So as Westeck, we deal with anybody who would come into the showroom to view our products. Also, we are asked for bid requests on any given project, single family and multifamily. You get designers, architects looking for what is possible before they enter specs into a project, et cetera. And then we'll talk a little bit later. There's a slide coming up, 2 or 3 slides, about how that initial request flows through our departments.
Okay, so when the answer comes back from you and it's no, what's the process you take? How do you work through that?
Well, the answer is no to start if we don't have a NAFS rated test for that product configuration. And based on warranty periods, raw material limitations, hardware or otherwise, linear lengths of vinyl, et cetera. The thought of potential customer dissatisfaction, sure, we can build it physically. We can weld it together. We can have longer lengths brought in. We can fabricate it. We make our products in-house, but because it's drawn up an architectural elevation doesn't necessarily mean that it's going to be what is anticipated from the end user, aesthetically and performance-based. And then also the inherent costs of going through customization and engineering. Engineering costs are one thing. Customization on the shop floor is another. If we're making new jigs, machining capabilities and such like that. So it does get kind of expensive. Those costs should be covered. Sometimes they're not, unfortunately. But essentially, if it's outside of a NAFS tested configuration or size, it's going to cost.
So you've gone through that process. You've maybe done some back and forth with clients, salespeople, back and forth, and now you've come up with a design that you feel that you can make work. So the answer now is yes to that non-standard, non-NAFS rated product. How do you deal with that?
Well, the answer would be yes, based on 2 things. If we do some work up front to qualify that product, or if we've done something similar in the past, and there's been some favorable service items or no service items on that, then of course it's yes. So if we can just go to the next slide then. So a simplistic flow chart here. Initial request comes into the project consultant or sales rep. The sales rep would use some in-house tools, spreadsheets and other graphs to qualify that product based on size and configuration and some other limitations. There's a few slides coming up for that as well.
Can I ask about
Sure.
that? So you have the consultant that has access to your ERP quote software. You have a order entry department. Is there a stop in place within that system that says, no, this has to go to Kyle and his people for review? Or can it get by you? Like, this is the question.
I would like to say that it cannot get by me, but it has at times. But there are flags and gates for that process within our ERP system. We input the NAFS tested size for product configuration, mullion spans, glass pane thickness, and hardware requirements, both maximum and minimum. So they would be challenged if they try to enter a picture window that is over a given NAFS tested size. That would flag. It would go through order entry and then into the technical department for review. So that's one of those flow chart items there. So once the technical department reviews a flagged item, we run it an analysis based on performance requirements for any given job, municipality, building height, exposure. We cross-reference our NAFS reports. It's one thing to look at a NAFS rating and see the PG rating and the water penetration. It's another one to go into the report and dig into it and note the deflection limits, the actual air infiltration, etc. So then technical department would confirm the initial design. We would cross-reference that design with purchasing and production to make sure that we're capturing all costs, that we can actually purchase that material, whether it's additional reinforcements or specific hardware requirements. We need to make sure that we can do that before we say yes. That also allows us to ensure that the costs, whether it's labor costs, customization, or upgrades to reinforcements, glass pane thickness, or hardware requirements, is captured in the initial quote. All that information goes back to the project consultant. They review, and then they can review with their customer to ensure that it's within budget or if there's extras to the contract, that's all under consideration.
How long does that take?
This is very much condensed. We do have other flow charts that have that whole process encapsulated. It won't fit on here. It may not fit on the black screen if we were to put it up that way. If you want to capture everything, which I think most of the manufacturers in this room would understand that it can be vast. If you want to service your customer in terms of giving them what they want and for a reasonable price, it is much more complicated than a yes/no scenario. I like to say no more often than I say yes. When I say no, it is why not? And then, well, maybe, I guess so. David gets involved. We could probably do it. These are the parameters. This is the logistical challenges. These are the costs.
Well, and I think any manufacturer, and certainly manufacturers like Westeck that build a lot of custom products, you can build anything. I mean, really, you can build anything, but it's about cost and, liabilities and all of those things that go into that. And that was always a fun conversation that I was able to get involved when I was asked to work with a customer or talk to a customer about a request. And that's what I would say. Whatever you want, we can figure out a way to build it, but you need to get your checkbook out and be ready to do some waiting and some back and forth. And oftentimes when you came back to them and said, yep, I'm going to build you exactly what you want, but the price is going to be, it was amazing how quickly they changed their mind on what they wanted. And that was often the case. Slide.
So I'll just go through a few of the tools that we use here at Westeck to help our PCs and sales reps qualify products. This is to speed up the process somewhat, so they would understand exactly what they're getting into based on what we have tested for NAFS, what we would be labeling as NAFS compliant, and then anything that falls outside of a simple parameter needs to be looked into. They would know that ahead of time before entering into the ERP system. So a simple spreadsheet here. There's a few animations rolling through. Yeah. So we list the product line. This is our 4300, just a casement window offering. Within the sheet, we note the performance grade as a NAFS compliant test result. And then it just simply goes down. There we go. Thank you. So our performance grade, the PG rating, water penetration resistance, air leakage, the tested size, and then also we go a little bit more in depth with the air leakage ratings, because an A3 is an A3, but it's also everything in between fixed and A3 in that threshold. So when we're dealing with project specific specifications and they're looking for actual numbers, we have this available for our PCs as well. So they can help qualify that product. Also, we do limit mullion spans, roughly speaking, down at the bottom, just as a starting point. We also utilize a in-house engineering program where we essentially build products to size specific and configuration specific products. This is going to be a little conservative on our end, which is a safe way for us to go outside of a NAFS compliant product. It's going to give us deflection limits. It's going to give us what section detail we need to utilize in this configuration. In this example, it's just a triple light picture frame, a PPP, and it's going to indicate where we have a mullion detail fail and where it passes. And essentially it's adding steel blades or reinforcement to that incrementally until we get a pass based on our deflection limit. It's also going to indicate to us our glass pane thickness based on just building code charts.
Is this your tool, or where did this come from?
It was developed by a structural engineer that we use locally.
Okay.
So it's not a Westeck
Right.
tool.
And are the background equations very similar into what David would be applying, so that you don't do a design work here and then take it to David and he says, no, it's not working. Do you correlate those? It's a bad question.
We wish it would be
it's
that
not a-
easy.
Yeah.
It's not a bad question. It's a good question. It's conservative, but it's not without its limitations. It's not looking at any structural anchorage back to the building structure. It's not really taking those things into consideration. It's a mullion reinforcement and it's a glass pane thickness. So we can adjust for building height. It's not a guard load calculation either. Yes, it's a little bit on guard load earlier. So it's kind of a conservative look where we can reasonably be comfortable that we're adding upgrades to any given product and capturing the cost within the initial quote before the customer sees it.
So it's going to save you from those surprises with those upgrades.
That's the thought process there. It doesn't always, but
And I'll add in here too that for the most part, to be honest, when they come and they submit it to us, I would say most of the time it's not bang on, but it is in the range that allows them to proceed forward. And so it is a good program that they've developed and that they use in house. So it really helps us out.
Yeah.
Because many times, we have other situations and clientele where that's not the case, and it always ends in.
What do
a bit of
you
challenge.
mean it needs reinforcing?
Yeah.
What are you talking about?
Exactly. Last thickness changes, reinforcing.
another tool that we utilize and the basis or the base of our discussion here is structural engineering. But most of us would understand that it's not always about structural. We have our thermal calculator here. This is based off of all of our NFRC certified values per product, per reinforcement, per double, triple glaze, krypton, argon, etc. So making a change to configuration or product line based on a structural engineering perspective also has its thermal implications. So loosely speaking, we have argon and krypton filled IGUs here. We can toggle the IGU configuration, grids, no grids, STLs, no STLs, etc. So it'll spit out our NFRC certified values based on our test results. And it's another tool for our sales team to utilize as a high level, quick look to toggle, not going into the ERP system and entering a whole home quote, having to change it for color, input the hardware selection, orientation of the window, and those sort of finite items where they can look at this quickly. If they're trying to meet a thermal performance metric and the configuration or product line is whatever it needs to be, then they can toggle through the U values or U factors, or if they're trying to target a solar heat gain at a high glance look, they can figure that out without toggling it per window. So if we're looking at a 1.25 a U value metric here, performance based, we can see that the two on the bottom, the 4300 argon filled or krypton filled, would be okay, more than sufficient. The 2300, which is a slattered product, is rendered out, crossed out. So no need to entertain that into the ERP system because it's not going to meet the values that you're looking for.
Very interesting. So, but this is just pulling data from certified NFRC values, right? You're not running calculations for different reinforcing or anything like that. Right?
No, that's correct.
Okay.
It comes directly from the NFRC, product directory.
Yeah.
We can export Excel files and it goes directly into there. So before we get into this one, were there any questions about those slides or tools or?
Okay, so the initial compliance process in-house tools for NFRC. Sorry, next slide. Initial compliance review. So walk us through, I know that we kind of touched on it, but just a little bit more detail about who's touching it, who's making those decisions, and what's being done by the people that are touching in very loose terms.
Loosely speaking, the request comes in from the sales rep. We'll go through order entry to ensure that the costing is correct. Anything that's flagged comes to the technical department. We sort it out the best we can. It's engineering tools, historical data, previous projects, etc. We compile the costs needed to produce such a window, and then it goes back through order entry to ensure that all the costs are accounted for, and then back out to the PC.
So that thumbs up comes off of your desk, correct?
Yes, essentially. Once we have consulted with all the departments within Westeck that are required, we can't say that it's a thumbs up, yes, we can build it if I'm not entirely sure that we can build it. I can't say 100% that it's okay to do if we can't ship that product. If we have to ship it knocked down in a mold assembly when we built it as a composite unit. So yes, it does come from the technical department. It's not without risk mitigation and to ensure that we can actually deliver and not find out that we can't deliver after the quotation stage, after our lead times, after shipping delays, after construction delays, and then finding out we can't do that. So,
Right. Good. Slide. So information for submitting. So just, again, a little bit of sort of rehashing kind of those processes, but a little bit more detail about what you need to get that work done as far as submissions go.
So we go about this in almost two ways. Initial review, if we're more likely than not to be awarded the job, we'll put a little bit more work in upfront. If it's unlikely or we're kind of putting a shot out there, we'll keep the details low. But essentially, when the in-house review is completed, we'll start gathering our data, architectural drawings, structural drawings of the building, anything that we may need or we think that RDH may need for their review once we're willing to submit. So we do take that into consideration because once perhaps a quotation turns into orders, when we really start doing all of the actual work and not just the initial legwork, and the clock is ticking. I'm sure manufacturers here would know. And maybe we still have some sales reps in the room that a lead time is a lead time, but it's only a lead time for a certain point in time, and there's a lot more work. Once the order's signed, they could say, well, our typical lead time is 5 weeks. Well, when does that really start? Does it start after we get the engineering completed and formally approved, or does it start when the signature is down? So that's argued.
There's no confusion with when lead times start, right? That's not a problem with that. Everybody knows. So I find that point that, sorry, right underneath the process together, the tech department is alerted that products on an approved order require third-party engineering. It sounds like you have a bit of a different process in there, that there are products that order entry already knows that, okay, this is going to require engineering, but it's not going through this full sort of review of, can we even build this thing? Am I reading that right?
Loosely. So that is correct. And we don't always need to get involved. We're talking about a picture window that we can run it in-house. That program, the glass pane thickness is checked based on the building code tables. We may, as a technical department, do an analysis on even a whole home or even one big window assembly. It may go out for quotation and we don't see it for 6 months. We may never see it. We may never come back. So within our ERP system, there's flags. Let's say in 4 months' time, they finally got signatures or there were delays and they finally got it. We've already forgotten about it, moved on. So it needs to be flagged and kicked back to us so we can just do another review to make sure there was no changes from the initial design in order to pass it on to RDH.
Right. Okay, so I'm a window manufacturer. I get somebody wants a window that is way outside of, or even slightly outside of what we normally do. I take a picture, a screenshot of the quote, and it has the one window on it, and I just email it over to David and say, it needs engineering. David, come on. What do you need?
So I can't tell you how many times I've seen that happen and have had that happen, not just with Westeck. And so very much so Kyle is you can see here in his hesitation a no man. In some instances, I'm a yes man. And so I like to say yes. It is going to cost you, but I do like to say yes. And you get to see my notes in here. So you probably already kind of read some of them. These are my trigger point notes that you get to see. There's certain information that we need to get and we need to receive. A small email with just like a screen capture, a PDF just isn't going to be enough. A NAFS report that is just a summary, and then we get that often where it's like, well, here's the summary page you need here, showing the NAFS report. That's not what us as engineers really need. We need the full report. We like information. We like digging into it. We want to ensure, because we are going to be signing off on that on a compliance. And so we will want that information. Plus, it also needs to be submitted to the authority having jurisdiction at the end, and or at least you have to have that on file. And so, we're looking for that full NAFS report. And why we're looking for, I just kind of went over, but also the report, we want to check and see, does it capture all the elements of the Windows system? Is it qualifying or able to allow us to use the ALMA 2502 to extrapolate information from that NAFS report on a sized window that is much larger or in between anything that you've tested before. We need building address. And so we need building addresses because we want to know what the topography is like. NAFS reports don't take that into account. Okay. When we're now getting into engineering, we are going to do everything we can to be able to qualify or bring that new window size to a compliance. So we're going to want that building address, determine the topography of the building. Is it rough terrain, open terrain? Is it on a hill? Do we have to consider hills and escarpments, that sort of thing? And in calculating the wind loads, if you use, for example, requirement performance data like from table C5, it's a maximum. And so that's like maximum wind values. And we want to be able to adjust as needed when we're extrapolating or interpolating the NAFS reports and the size of the window you're wanting to use, so that we can do that properly and correctly. Building architecture, the architectural drawings, structural drawings for the building, we're going to want to know this so we can calculate the wind load specific to that one building if that's what we need to do, other than using a table C5. Fabrication drawings, we want to know everything about the system. We want to make sure that it is the system that you specified. I can't tell you how many times I've seen that where they're like, oh yeah, here's our system. And then we get the NAFS report and they don't match. And then we're kicking it back saying, hey, it's not matching. Or you know what, maybe it's an older, you've made some improvements or some changes to your profile and it's close, but it's similar. And so we're going to want that. We're going to want to know that there's differences and not be surprised at the end with hang on a second. When we get those fab drawings, because we actually had to go from first principles, they don't match anything of test report. And then if it doesn't match a NAFS test report, to us, that NAFS report is like null and void. It's like set it aside and we're going right to first principles and we're going to have to engineer it, which can drastically change your engineering costs. From a simple review of doing a comparative analysis of an ALMA 2502 to a full-blown engineering, review of your Windows system.
So they should be asking themselves when they're looking at all of their documentation, do they need this one? The answer is just yes. Just send it. Right?
Exactly.
And you guys will figure out what you need from there.
That's exactly it. The more information, the better for us. Information about the project, your Windows system, everything, whatever NAFS reports you've got. If you're mulling, systems together, if you change them, whatever you're doing, like send us all and full reports. That way we're not going back and forth and there's all this wasted time, because by the time I go through and look at the information, if it's not there, then I'm sending an email back, right? And so days start going on and time just continues to go. Then there's a due date for an installation and it can just really delay it. The engineering process can cause, a delay, especially if we're going to have to go to first principles in engineering.
I would just like to point out, I think David called me a no person. I prefer to be risk adverse than a no person or a no man. But I get
I like that. That's much better.
Do you happen to have a checklist of what needs to go to RDH? Like you guys, have you drafted something like that?
we don't necessarily have a checklist, but we've learned from our mistakes and errors. And though I would like to say that some of what David's saying is about other manufacturers, but It is, but also some of it is Westeck.
There was definitely an up curve, there was a learning curve, right?
Yeah.
And so as Colin and I started working together, well, as Terry, as we started to work together in the beginning, there was always that, okay, that's great. You sent us the information here, but I don't know what reinforcing it is. What's the aluminum? Is it aluminum? Is it steel? What's the steel, properties, everything about it. And so then as we got through that with Terry and then Kyle, we learned what he knew what I'd be asking.
I think the comment about the NAFS report being irrelevant is key, because when we're using swing door systems, we have in-swing versus out-swing, transoms, banked assemblies, mullion spans, SDDS, side lights. It's vast, and we could use 10 to 12, 13 different NAFS reports to try to qualify one door assembly from any given configuration. So recently, we've been sending out NAFS reports or indicating where we think his time is best utilized in NAFS reports based on this vertical section. I think we can grab from NAFS report X and Y. Then they're not necessarily looking at 15 or 16 different NAFS reports to try to pull it together, because that takes time and costs money, and the clock is always ticking. In the customer's eyes, we have already sorted it out just by simply saying we could. Not necessarily that we should.
So that's a really interesting point that I just want to get some clarity on. So you know that this assembly that we want to provide, I have 3 different test reports, but within those 3 test reports, there's some commonality, but also some individuality of what those covered. Is that in RDH's eyes? I mean, here's 3 test reports. They're not all the same, of course, but there's good crossover between what they are and what this final custom product needs to be, that you can utilize performance results from 3 different reports to say, yeah, I think we're good here.
And that's exactly it. And that's what we're trying to do, is utilize the information in the testing as much as possible. We don't want to go into first principles engineering because it is so much more involved from an engineering perspective. It's not that we can't, it's just, it really is. And so for us, following a nice engineering compliance is kind of like a flow chart, where the first part of it here is really would be like what Kyle and Westeck do. And so they're going to determine the performance criteria your product needs to meet. They're going to check that the product meets the required class and its grade. They're going to go on to check to determine if your product has been tested to comparable size and wind load. And if so, and it's compliant, they're going to fix the permanent and temporary labels on it, and it stops there. Moving forward, then if it doesn't, then it starts going to, if it's not compliant, then they prepare the documentation. They're going to submit it to us to review that documentation. What is it? It's 5 things: the full NAFS report. It's the building address, building drawings, performance rating, and the fabrication drawings. That really gets us started. And that's the information that is most important to us. Then what we do is we like to submit an initial compliance letter to the authority having jurisdiction, because we know that there's a possibility that the authority is going to lag, ask us. And so thanks to Ali Galis, I'll be honest, who helped and developed this, we have a letter we've developed that we submit to the AHJ, asking them and letting them know and teaching them about the compliance path and what the resources we're going to use, and that we want them to comment on it. So then what we'll do is have that submitted. We don't have to do that all the time. And so, but we have it ready for when we need to do it. And I'll kind of talk a little bit about that in a couple other later slides and go into what we put in that letter. And then we're looking for their permission. And it's great when we've done that, because when we've submitted that initial letter of compliance and it's educated them, and then they allowed us then to proceed forward, and then it goes quite smooth. And from then on, they know what to expect. They know they're going to get a final compliance letter and what information is going to be in it. Once we're done that, we do a comparative analysis review or an engineering for structural components. So I'm going to state this: for structural components and structural review only. Okay. And so that's what the comparative analysis of ALMA 2502 allows us to do, only structural. It does not allow us to extrapolate or interpolate that NAFS data for air and water. Okay, I'm going to talk about that in another couple slides later on, because that is something that you will possibly have to do. And so then once we get through the structural part of it, we do a final compliance letter submitting to the AHA. I'll talk about what's in that final letter as well. And then if you need, then there's testing on site for air and water and infiltration compliance. We hope most of the time not to have to get to that point, but it is a reality and something that you as a manufacturer want to be prepared for, because we have had it come up. And so I'll talk a little bit about that as well. So if you click to the next slide. So for us here, I kind of like summarized a lot of this anyways, but our initial submission is managed like we'll review the NAFS test reports. We do a comparative analysis, I've said before, in the 2502. A little bit of tidbit information is that the latest version is 2019. However, they didn't make it into the BCBC 2024. Thanks very much. We engineer the glass makeup, and we engineer the fastening system if required to do so. And as you can see my note in the bottom, glass and fastenings are not covered by NAFS test reports and are designed per project. NAFS does not test the glazing nor the fastening. And it's a good thing too, because most of the time we see in those NAFS reports, either the fastening is noted in there and it's some very ridiculous close spacing, or it's not there at all, or hasn't been noted down, and rightly so, because that's what NAFS is not testing for.
Has that come back to you where you've dealt with a client and you have done structural engineering design on an assembly, and it goes back to them, and all of a sudden, you know, you want 6 mil glass? Do they not sort of get that, yeah, the structural is this whole thing, not just the frame or the mullions?
No. So they don't get it. And that's something that, you know, unfortunately, I feel like NAFS kind of hides and hasn't really informed or educated on, because we will come back and say, oh, hang on a second, you know, based on your test report, here we go, but you have a window that now has guard load, for example. And so we apply guard and wind load on it, and now she fails. And so it's always a surprise, and it's not a very nice one. When we're looking at our comparative analysis, you know, another big hint about when we do comparative analysis, if we have a test report, let's say you have a project has a PG 20 ready. This just happened to us this week. Client has a job, oversized window, and they have a test report, NAFS test report. Highest they got to was PG 25. The site requirement, PG 25. I'm gonna have to look at the report. When we do a comparative analysis on it, because the window size is larger, a lot of the time your PG or the design pressure drops. If your test report isn't at least 5 pounds per square foot, like higher, it's not going to work. And so we're going to have to start engineering it. And so that's just something to be aware of, right? Because, it's I know, sorry, it's a bit of a math thing. And so when we're doing the comparative analysis, it's like you tested your window or this size of window. For example, let's say it's 1 meter by 1 meter, and you reached a PG 25. And your site is rated for a PG 25. So that's the requirement, the performance requirement you're supposed to meet, but you're oversizing your window. So when you oversize your window, the comparative analysis, when we do that, pulls the design pressure or your PG down, but so you had no room to even extrapolate.
So that
And that's
made me think about something else. I have a window that I've tested. I have a report for it. Let's just say for fun, it's a 6 foot by 5 foot single slider.
mhm.
I got a PG 30, let's just say. The job site is PG 30. I want to make sure I get this. Trying to work the engineering into it. And why I'm trying to do that is that PG 30 on that slider is not a PG 30 engineered slider.
Correct.
So if that window, okay, actually I got the scenario. 6 feet by 5 foot slider, PG-30 test report.
Yep.
The project requires PG-30, but I've made that window 6 inches bigger. Or maybe even they need a
So-
PG-25. You
I was
get
gonna
my
say PG
gist,
a
right? What I'm trying to
PG-25.
get at.
So let's say it's a PG-25, okay? If it's a PG-25 is what they need on site, your test report has a PG-30, but your size of it is, let's say it's 6 inches taller. When I do a comparative analysis, your overall rating of the NAFS report, PG, drops down, and hopefully you get it above the 25. We can get also project specific, but then we start getting to first principles as far as like wind load calculations. So when we can't use the 2502, then we have to go into first principles, and we're going to start calculating section properties, the actual wind load for the project and everything like that, and asking for, a different compliance.
You know what I was trying to drive home to was that my PG-30 is an LC class product, but if you need to get involved at all, it now is, you're unable to provide me engineering for an LC class product because now we get into deflection limits and things, right?
Just
So that was the
gonna say
point I
that.
was trying to drive to.
Exactly.
So just up there, you're talking about including installation details and attachment and guard load and all the extra things that come that a window has to meet that NAFS doesn't cover, right?
Correct.
So what I've been trying to change the narrative a bit in this issue because you get a lot of requests from window manufacturers across the country, especially ones that aren't in BC that are starting to sell in BC. I just want a NAFS letter. That's what you get. So your title, I want to go back like at the very start, you said engineering for NAFS. That's not, I'm going to criticize that a bit
Yeah.
because it's NAFS or Part 5. So you don't engineer to NAFS. And I think that's the service we're doing to the industry by saying we're engineering to NAFS. You either test to NAFS or you engineer to Part 5. And what most aren't aware of is when you engineer to Part 5, you're obligated as an engineer to increase the scope. So window manufacturers that have made a decision for their compliance path to be Part 5. So let's say they only tested 50% of their thinking, oh, we'll just use Part 5 for the rest of our product lines. They are opening a scope significantly bigger. NAFS is actually an easier route for a manufacturer for compliance. Just do more testing.
Correct. It is much easier. And you're right. It is
And the reason I bring it up is because the Part 5 path we've been using in BC since the start of leaky condos with engineered shop drawings. So we have a really well-known system of how to do it. And that's why when you see manufacturers outside of BC trying to navigate this world, they get really confused because it's hard. Unfortunately, there's a lot of people out there that are doing NAFS engineering and they're providing a letter. And just recently, Burnaby has started rejecting the letters. So they will not accept a structural letter anymore. They want letters of assurance covering the full scope of Part 5. They've caught on to this issue. And so they're either asking for site testing with a letter, but now they're wanting letters of assurance. And I'm kind of going, you have a multidiscipline engineering skill with Part 5 for Windows that you're not getting this one-stop shop. So,
and that's correct. And I'm glad you brought that up. And in our wording, it's right. Let's not get mistaken. There's the NAFS test report, and then there's Part 5.
The title should have been, if I may, engineering for products that are within the scope of NAFS.
Exactly. No, and I'm glad you brought that up. That's a very good point because we do not want to get that mixed up. A lot of what we do. So in my compliance letter, I am not saying this is a NAFS. Like we don't say that at all. It shows the code clauses in Part 5 of the building code that we are going, and it is explaining how the product does not meet the NAFS, and this is what we're doing, and the resources we're using to qualify this one window or whatever window product that you have that doesn't meet the NAFS test report. And so it's specifically covering under Part 5. And however, we do try to limit it. Like I said, we do limit it to the structural part of it. If you start to get into the air and water, we do have to address it, which Anton is correct. And we have had that. where the authority having jurisdiction has asked for schedules specifically. We are very fortunate at RDH in that we can and we do tests. And so we do on-site testing for air and we do on-site testing for water. And then we'll fill out the part 5 for air and water once it has passed. But then that's a whole different ball game, and that is expensive.
Back and forth. There's, I mean, I know, obviously I've been there. It can go on for a long time, the back and forth, because there's so many players that can be involved. Obviously, Kyle and yourself are back and forth, but now it's back to the rep, back to the client, back to the builder. It can go on for a very long time. So I'd like you just to kind of touch on how that process can be frustrating, I guess, for lack of a better way of putting it.
It is frustrating. You forgot the flooring person.
Oh yeah, that's right. The
Yeah,
flooring
guy-
person is
guy
there
putting the
too.
flooring
That's
in
right.
too. He has a say. And I say that kind of jokingly, but if we did a installation attachment to the sill of a patio door or a window where we utilized installation angle to the interior, well, the flooring guy doesn't like that. He's unhappy. Or if we went to something that is deemed intrusive with a post to the interior of a mullion, well, the flooring guy doesn't like that. So
So
trying to go
I
back
guess
and
maybe
forth.
the sort of the key takeaway to that is you need to make sure that whatever this design looks like when you get to the finish line, everybody that is a stakeholder in the process needs to be aware that things that need to be done for this product to be compliant can have impacts in a lot of other places.
Absolutely. And it's lots to think about.
Yeah.
I make a joke about the flooring person because I hear that quite often, but it's the person doing the blinds.
Yeah,
It's,
sure.
you
Yeah.
know, certainly the homeowner doesn't like the thought of having a post to the inside. If we look at these 3 windows up above the front entrance there, similar situation. There's a horizontal steel post at the center point of those windows. Those are vinyl windows. Now, that post needs to be there. It needs to be anchored back to the concrete structure. That may, the homeowner may like that size of window in the configuration based on the architectural drawing set. They may not like that post on the inside and don't want it. What do we do? Well, David has said that we need a post there. Well, we need a post. What do? I don't know. We have more back and forth.
Yeah. It
Always a
comes
lot.
back to that. I can build it. I can build it. Build whatever you want. But there's going to be some give and take on what's acceptable and what you can live with and what you can pay for. Right. So
Well, exactly. And then there's limitations, and there's limitations to what we can achieve and do, you know, even in our engineering, how much reinforcing you can put it into a mullion, or what it looks like with, oh, you know, you're having to put some reinforcing on the exterior. No one's going to like this. There can be a lot of issues.
Something as simple as attachment back to the building on an intrusive post like that is problematic. Here, it's an industrial building, not a huge deal. If you can see the brackets on those horizontals, those are exposed. Customers don't like to see things that are exposed and anchored back to the building.
but if you're in the game early enough and you deal with the builder or the finisher or whatever, there's things you can do.
Yeah.
Right. To make it less intrusive, if you like.
That's true. I often make the comment that there's the granite countertops in the driveway. They don't have a window supplier. The roof is on, everything's papered up, and they still haven't figured that out. And that limits us in design because we're working around somebody else's design and trying to figure that out. So David could say what would work. We often ask for 2 or 3 different options. Post versus I-beams, geometry of the post, interior reinforcement. When that comes back, what else do we do? Well, maybe we need reinforcement horizontally and vertically. Maybe we need to reduce the size by 4 inches in height. Maybe that's the kicker if that design can go.
The options, right? Thinking about that back and forth with whoever the stakeholders might be. You go through the process, come up with a design that is acceptable for engineering. You go to the client The rep goes to the client and client says, well, but window company ABC doesn't need to do all this stuff. You know, what's the problem? What are you guys doing to me? What's the response to that?
Well, me being risk averse and perhaps a no person in this aspect, I would ask them to prove it. I say that anecdotally because nobody does. Or they may be able to do it without those mitigating factors, but they're not going to be doing it properly, in my opinion, or as best as we can do it. Now,
I agree.
Yeah.
I agree with them on that.
Yeah.
100%. We see the same thing come in where, not with Westeck, but where we get scenarios of it's already installed.
Yeah.
And well, you know what I mean? And I'm 100% certain that they play between ourselves and Leighton all the time. And it'll go to them and it'll be a no. And it'll come
Leighton
to us
approved it.
and it'll be like, no. And that's what's great to be honest. And I bring them up and I do it smiling because it's so good to see that we are on the same page for a lot of those things. And, because we'll see that and they're like, well, on this job, it got approved. And I'll say, you know what, it's however they got through it. That's a mystery to us. However, here's everything we got here to show you.
In the window and door industry, we have nefarious players. I'm sure that in the engineering industry, there's some nefarious players. So stand your ground. No, Marie says. Yeah, enforcement. Enforcement is a topic for our next event. Yeah.
Exactly. Yep, they got away with it. There's some way, or they wrote a NAFS letter.
Slide. Okay, so documentation. So final submission for engineering is submitted.
And so we kind of already went through a lot of this already with the, drawings, glazing, structural components, things we look for. And now I want to quickly cover what we put in the initial compliance request letter and then what we will put in the final one. And I'm sorry, but these are my notes.
I was supposed to take them out. My apologies.
No, it's good. It's all good. No problems at all. And so, we basically we lay out the evaluation measures proposed. We're going to reference the BC Building Code section 974. We're going to put these in here to explain and basically I'm trying to educate the authority having jurisdiction so that they will look at it and go, okay, yes, I understand it. I can look up the code. We're not hiding anything. It's all right here. Look it up by any means. And how we're going to use these standards in order to do our evaluation. And that's what it is. It's an evaluation to part 5. And so then as we've done this and explained it to them, and we're also explaining that, this is what it's covering and what it doesn't cover. And then once we've done that, we've done our analysis. And if everything has worked out, we've been able to extrapolate using the standards here, then we have our final letter that we submit. And when we submit that, we say, here's the limitations of our evaluation. So it's clear. We say what exactly we used, and we include an appendix which has, and you have to and should do this, the NAFS test reports. It should have your window system fabrication drawings and drawings showing the location of the reference window. So we want to include all of this information. We found, and this is RDH's opinion. This is what we've done, and so far we've had good success by submitting these letters, and we've had good reports back from authorities having jurisdiction, and good responses, and it's had really good and positive outcomes. And because of that, also, with Westeck, we don't have to use it as much because the AHDs will then start to understand and know. Let's go to the next slide.
So the manufacturing of the product, once all of that work behind the scenes is done, you have to deal with putting it together. So maybe take us through.
Sure. So once that final approval comes back from RDH, we would have that final drawing set done. Those are elevation drawings, floor plans, if required for that, cross-section details and installation details. That's all inputted into our ERP system. Anybody can access it. It goes down into production. Production would also have purchasing. They need to order the parts, not only the parts that are required for the structural aspect, but secondary parts, cover caps, additional screws for fastening, anything along those lines. So Once that comes through, it goes to production and purchasing. We purchase the additional items if we don't house those already. Um, the production team, the technical team, if required, we would have a meeting of sorts to, this is how this window needs to come together. And we're not talking about a small window like some of these ones on tops, they're larger ones. Even window wall assemblies that are going not down to site because we simply can't ship them. So we come up with a strategy of sorts to make sure that those are manufactured based off of the approved drawings from RDH, making sure that we can rightfully say that we produced as per final drawings approved by RDH. We shipped, we installed as per installation instructions approved from RDH. All that goes into our system and it's kept there. We can draw back on it, and when we're questioned from building officials, 6 months down the line, 1 year, 5 year, even warranty providers, if they're looking for something, we can pull back into our ERP system for that specific job. We have drawing sets, any back and forth and emails go into there as well. So it's all captured there.
So the relationship today between RDH and Westeck obviously is now a pretty long one. There's a lot of history, a lot of work between the two companies, and you know, certainly a level of trust built up. But I'm curious about, you know, are engineering firms doing any site factory visits? Did you guys do what I told you to do?
That's a great question. No, because it's and this is and it's very interesting. It's a disconnect because all we are doing is looking at part 5 of the building code for the structure of the windows. So what we are ensuring that it is compliant to certain performance measures for that building. We don't get asked to provide, or we haven't yet, except for one spot where asked for to provide schedules. And if that's the case, then we have to
Different world,
educate.
right?
It's a different world, right?
yeah.
And so, like your NAFS report, and this is where I'm not sure that the HJs are understanding, or this is all they've asked for and gotten to that point, was they want that compliance letter saying, okay, we have evaluated, we do find that the new sized window is compliant to the performance rating that you were wanting to achieve. And then that's where it stops.
So without getting into projects that like you know, that include schedules and that,
Yeah.
you do an evaluation, your company does an
Correct.
evaluation, you provide the details of what that product, how it needs to be built, but there
Correct.
really is no responsibility on you that gets built like that. That's up to Westeck or whoever the
Correct.
manufacturer is.
And
And
so
it's
that's
their liability, it's not yours. You've simply provided guidance on, to meet the requirements, this is what you should do.
exactly.
Okay.
And so we have a lot of trust
Yeah.
and in the companies that you're working with, and that's with Westeck, to know that they're going to follow those measures. But that's where it stops.
I have seen site visits for install details. Is that something that you get involved in?
It is something we get involved in if required. And if the request comes from the HH, for example, like Anton had mentioned, where now we're starting to see that. So even for part 9, if that it isn't a NAFS compliant window and we're following part 5, they're starting to follow through. And that is right within Burnaby, where it's like, we want the whole thing done then. And then we do that. We go out, we'll inspect it, we'll ensure that the installation of it is in accordance with the engineering requirements we specified.
I know it never happens anymore, but a little bit of experience from my past when I was involved in the early stages of getting into doing this kind of process. And I mentioned the manufacturing overview and, you know, is it built as per se? There was a window that we had designed, had support from an engineer. The details were put together, the drawings were done. In fact, it was something like 6 light window, you know, 10 feet by 10 feet, whatever it was, horizontal mullion that ran through, I think, if I'm not mistaken, and then mullions that were split top and bottom. And the verticals needed steel of X, whatever the design was. All good. Goes to the floor. Here's the drawings, put it together. No problem. And I just by pure chance, I was on the floor. I thought, oh, that's that window I was working on. And I went over and looked at it. Well, the steel was in the mullion above the horizontal mullion, and then it stopped, passed over the horizontal mullion and started again. So, you know, I know that that's something that manufacturers with experience and that do a lot of this, they've figured out how to deal with that, where you can run steel through mullions that cross, things like that. But, you know, early players in this world, and I know that we have some in our market that have gotten into projects, you know, where structural design comes into play, and you have to question sometimes, well, what's going on in those products and if they've done what they say, right? So anyway, just something came to mind talking about reviewing the product as it's being built.
And that's very much, you know, with Westeck, that hasn't happened. And that's what's great.
Oh, it wasn't Westeck.
And I can, oh yeah, of course not. But I'm sure Leighton can understand and have had this happen. We had something very, very similar to that situation just come up this past week, where we had done the engineering for it, and it's all installed. Months have gone by. No one expected, or the client did not anticipate needing and requiring schedules. And just this week asked us for schedules, and we said, well, that's great. We've never been to site. And so we started to go to site. All the reinforcing we had asked them to put in, you can't see. So we take a magnet. There's no reinforcing in any of it. And so now, you know, that was as of yesterday. And so, you know, it's an unfortunate, I think, disconnect at sometimes, in that the AHJs then will just take that letter and they'll stop it there. But that's what they're requesting, and hopefully the system will get better over time.
I think I'll just make a comment on that before we move on, Terry. I think that with any given system, even the one you were speaking of, the 10x10 6 lighter, we could have attempted to send that to a lab and have it tested under the scope of NAFS, and it would have deflected 4 or 5 inches out, not broken, hopefully, at a PG20. Is that an acceptable product for the customer? You wouldn't have to go engineering route. It could deflect 4 or 5 inches and still be okay under the scope of NAFS. Is that acceptable? It's acceptable under the building code. Yeah, exactly. Yep. And another comment about the discontinuous steel. I think that specifically for Westeck, when we did and are moving away from metallic reinforcing as we can, all the metallic reinforcement needed for the stiffness of the steel to the inside of the window. Then basically that, yes, exactly.
And I've seen what you're doing, and it
Yeah.
looks great.
So that way we're not infringing on the U factors or perceived U factors, and all the steel is to the warm side or the conditioned side of the home. Then you could physically see the steel. It's intrusive because it's coming to the inside, but that's almost where things are going to need to go, or for us as Westeck anyways. And then
Yeah, when people
you can
talk
knock on
about
it and not use your magnet, you know, it's
Exactly.
when consumers or whoever, when somebody comments about, well, no, you can't have that sticking into the house. Go to any commercial building, and it's all protruding inward from that product.
and more often than not, if you were to do a HSS post 2x2 or 3x3, it's doing all the heavy lifting. If you were to move all that structural steel to the inside of a mullion, if you could fit it, unlikely. What's it doing to the U factors and that? It's undetermined.
We're gonna find out.
Yeah, so that's why I mentioned fiberglass reinforcement where it needs to be, and steel structure to the inside where it's always warm.
Okay, compliance documentation. I've gone through the process, worked with RDH, got the design, built the product, shipped to site. What are we dealing with as far as showing anybody that has interest that that product is?
Anybody having interest is a key comment there. Typically, we would label it as an engineered product, and with all the backgrounds with us, when we're asked to provide approved drawing sets, we do. It's all been squared away. So it's a formality at that point. And we have had that request at times, not all the time. I think some building officials and inspectors see a label on it, may not even read anything about it, and carry on their way. But we would label it as an engineered product based on that size.
There's lots of that going on for sure, where they just, there's a label and they keep going. And I hope I don't call you out because I can't remember how we dealt with this. But on typical NAFS labels that are backed up by a NAFS report, it says on the label that this product conforms to NAFS, blah, 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 blah. Well, listening to comments that Anton's made and some of the discussion here, the reality is that product is not a NAFS conforming product anymore. It's a engineered product, or however you would phrase that. So I'm wondering if you keep that verbiage at the bottom of the labels on an engineered product.
We do still have that on there, and nobody's once brought it up. And maybe it's overlooked. Maybe it's a terminology thing that's similarly brought up.
Part 5 changes in the national code has sort of triggered all these conversations to come to the top again, which I think is good. I've actually kind of thought of, you remember the labeling guideline that FenBC did? It almost needs its revision or addition or an update. Ken? Sorry. But I've actually had this idea of product that uses part 5 to have a label on the window that just says product conforms to part 5 point blah, 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 blah. Please see, for verification, refer to a report dated or refer to a report. That way, a building inspector walking around, because as soon as you don't have a label on a product, the building inspector, it's a red flag that goes, oh, failed, then there's going to be a problem. And then you get this sort of really frustrating conversation that goes on. But if you actually had a letter or a label that said part 5, I think it actually addresses the issue. And so nobody truly knows how to properly label a product either that uses AMA 450 or AMA 2502. That's another issue. Because if you're using AMA 450, technically you can put a NAFS label on the product because the engineering's behind the scenes, hidden, and you can't see it. So it's a bit of a sneaky way. It's not tested to NAFS. It's still engineered to NAFS. But I think there's a time now to update the labeling system that brings more awareness to this process. And then if you look at the national level, because we're like, let's take product outside of the scope of NAFS, you could still technically have some sort of labeling program for product, which just makes it easier for building officials. And it might actually help address the issue about letters of assurance and all that sort of thing that comes as this request when you technically don't need to. And that's where I think we need to stitch this together with building officials to make it simple.
I actually have a calendar reminder that's about 3 months old that says update the NAFS labeling document. So I'm going to add your name to my reminder. That's great. Thanks. Okay. So structural air and water. I know we've talked about it.
Yep.
And you do not engineer air and water. Everybody knows that. So how do you conform to the air and water numbers in an engineered product? What's your thought process? And, do you get challenged?
We rarely get challenged.
Yeah.
Now, I think that we have a benefit at Westeck with a wider range of NAFS test reports.
Yeah.
Yes, and there's dozens and dozens on them. So we are open to be challenged, and we have done some site testing as Westeck, though we're not necessarily set up for that. But also there's been other third-party firms that will go in and test the product. And then we run it through a similar way as we do with multifamily buildings, where we attend and we inspect, and we go about it that way. And then I've not yet participated in an air test on site, regardless multifamily or single family. Certainly water tests. So when called upon, we respond in a similar way as we would with a multifamily building.
So the reason that I wanted to highlight that is there was a situation that happened with a Canadian manufacturer within the last year or so, supplied product, PVC slider windows into a multi-unit building that in the specs and the contracts did not ask for engineered drawings. So that's a problem, but whatever. So the manufacturer had NAFS tests for their slider windows with pretty decent numbers, and had NAFS tests for picture windows that had good performance. The window design and both of those performance values met the requirement for the location and the building type, like building size, the building height. The company used their own internal engineering to design the products for structure. They were approximately, and I'm just kind of a little bit of guessing, they were about 8 feet by 5 feet, pictures over sliders across the bottom, one window, integral composite design window. No problem. Building's finished. Everybody's happy. Some events happened. Somebody started to question the air and water performance of these products. So they tested one of these windows. And again, all top glass, 3 lights, bottom sliders. I don't remember the exact sizes, but the sliders failed miserably because all of this sheeting water coming down onto the sliding window. Long story short, about 1,000 windows removed and replaced by another company, and a significant lawsuit. So air and water, I think we need to start being concerned about, will this design perform like I believe all of my test data is? And had that window been a slider on the top and fixed on the bottom, probably never would have been an issue. So anyway, just air and water, I think, is something that we're going to see, potentially going to see more challenges on some of those numbers.
I think likely in that situation, the specification ought to have called out a mock-up.
Yes.
We see that
Well,
often.
it's interesting because you touched on it a little bit earlier. The building was already, 3/4 of the way up, and it was like the best price, and I need them in 3 weeks, and scrap all of the concerns about drawings and performance and testing. Yeah.
A lot
But
of
they
this,
lost. They lost.
I believe that, but a lot of this situation, like David's calling me the no man and risk adverse, it's all a consideration. Some of it, we say at Westeck, we could, but should we?
Well, I can tell you, I've approved products that have kept me up at night many, many, many months later. So we all tend to, sometimes we'll take a little more risk than we should. No, it doesn't happen here. No, that was in my other life. That was before. Okay, so how is a challenge to a product compliance managed? So you engineer a product, you get it out there, it's got some labels on it, but some sharp building official or somebody else potentially says, hang on a second, I don't believe this. How do you deal with that?
I think I've been fortunate enough to, when challenged, to have logic prevail. We have our approved drawing set from RDH. We've gone through it all. We have our other NAFS reports. It all kind of ties in to make sense. I could see how some manufacturers may have a challenge when challenged. But we've not had the opportunity to really dig into a challenge like that, to be honest with you. We try to do the work ahead of time, not only to capture all the costs, to make sure that the end product is what is dreamed of or required by the client or the homeowner, all in the attempts to not be challenged, have everything set up where maybe we're challenged once or twice in a certain municipality, and then I don't know if this happens, but I like to think of it happening where the inspector said, well, these people usually do a well enough job that I can challenge it, and I'm just wasting time and go back on it. I don't know if that happens in reality, but I like to think about it like that.
I recall a situation at Surrey City Hall many years ago of a product that was challenged. And I sat down with the building official and the head building official, and I had some engineering data and about 8 test reports. They looked at me and went, okay, thanks. Prove that you are at least doing your very best to be as compliant as you can. And I think most building officials appreciate that and understand that it's not always possible.
And that's it, and what we've shown here is the due diligence, right?
Yeah.
It's showing the low path. We're not hiding anything. We're showing and asking, this is the compliance. This is the evaluation method we're following per code, and here it is. And so it's nothing that Westeck or RDH is hiding. We're showing it to you here, and how we feel this evaluation has justified, qualified the window for this performance grade.
I really liked what Kyle said, and I think we, as engineering professionals, we think about it all the time when you said, when you essentially signed documents, that your client's under the understanding that you've already figured it out. So is it, and like, we don't like, Dave, and I'm sure the same, saying the design isn't going to work. Is there something that the window manufacturers could put forward saying, like, I have to get this qualified? Like, is there some way that doesn't make you guys feel like that there's this tension that's built in, like, I hope this gets through? Risk aversion is just bleeding out here. Yeah.
We attempt many things at Westeck. We attempt to put it to our customer or client if they would like to provide a nominal fee for engineering upfront based on the design. We can do that. That way they can ensure that things will go or ought to go the way that they want, or they would be more prepared to deal with any changes. That doesn't happen very often because we're often not awarded the job until it's actual go time, and I need these in 6 weeks. So for Westeck to reach out to RDH, we have at times, but preliminarily, to put cost and resources into doing that upfront, to not be awarded the job doesn't work out very well. So currently, I think the best thing that we can do is be upfront with our clients. We have line item notes in the quotation. This is subject to change based on engineering costs and design, et cetera. That never goes over well. We can discuss potentially pushing out lead times, because I think that we do our diligence upfront well enough that it's possible. We just got to sort it out. And then also with the back and forth with RDH, we have a reasonable time frame. If we know that we need windows on site to be installed in 10 weeks, and the clock is ticking, we need to make that work within 10 weeks, whether that's twice a week, Teams calls, going over designs, what's possible, what isn't, a little bit of back and forth there. We allow lineal footage to be painted, vinyl windows. We paint lineal foot. So that comes down the paint line. It's in the production queue. We have allotted times to produce. We have our installers tentatively scheduled. It's all trying to meet into the middle. That doesn't always work out very well. At times we have had to do something where the customer wasn't super happy with the end result, with more added posts than originally designed, but with no other changes to configuration, whether it's additional mullions to help take up the load or reduce the height or width in any geometry, that would go. It's unfortunate, but that's kind of the risk in getting into windows that are oversized. If everything was a NAFS compliant size, then there's no risk. It could deflect as much as the report notes it to under class LC or R, and they might not even be happy with that. They may be unaware that that's what's happening, but that's the reality. So we try our best. It's not always perfect. The give and take and the back and forth gets better as we go on. And actually currently we have 3 large windows on a back and forth with RDH, and one of them is particularly problematic. We won't get into too many details, but it's a large polygon window. It is massive, and one of the deal breakers for Westeck to even be thought of, it's 12 lighter and triangles, was that each triangle had to be the exact same size daylight. So we can't reduce the height, we can't reduce the width. We're talking about dead loads, and it's spanning a floor, and there's all sorts of other things that we need to sort out, and we're almost there. We're not quite there. I think that we were given a 10-week, Jessica was a 10-week lead time. I think that was 4 weeks ago. We're, it's been ticking. And I think that just being open with that communication back to our sales rep and the customer, like, we're working on it. These are the hurdles. We're not, like David said, we're not hiding anything. This has come up. This is an issue. Here's option 1, 2, or 3. Which would you prefer? They prefer to have it as drawn in the architecturals that came out 12 months ago. It's not reality.
But what's really good about Westeck and Kyle and his team is, they have such a, I might tease him that he's the no, but it's his risk mitigation, honestly, and knowing the product, the test reports, our relationship and what we've developed over years allows him to know, and their team to know, the limitations. And whenever they're kind of like, well, hang on a sec, this is a bit of a riskier one, we will usually get a phone call to say, hey, this is out of a parameter we're not familiar with. And before they've even given a go ahead, they'll ask us at times for our opinion. Can we have a quick look at it and let them know, is this something that we can, can we pull this together for the client?
I think I was going to sort of say there's a bit of a cultural engineering issue, I think, at play here with the industry, because nobody complains about engineering costs for trusses, right? Railings, like, we all know that that's a vital aspect of that assembly. Engineered beams, they're just, it goes with the course, right? They have to come out, they do site. Why do people complain when we say we have to come to site to do an inspection? Does your truss engineer come to site? Of course they do. So to me, this is a cultural thing that lacks awareness, and it's just pure ignorance. And I just had one about a couple months ago where I was laying out what we would be required to do in order to do a Part 5 compliance path for this house, for this package of windows. And when I told him what we needed to do, he goes, well, maybe I need to hire a different engineer. And so this is where I'm glad to hear what you say, because there's alignment back and forth. It's like perfect. But I think this is an EGBC thing, because there is no defined Part 5 path for how to deal with this. And it's for the decade we've had NAFS and the BC Building Code. I think we've talked about this maybe 5 times. Like, we talk a lot about testing and all this sort of stuff that goes into it, labeling, but we don't talk about the Part 5 path enough, about what an engineer can and can't do. And so this is probably the first time I think I've seen a good presentation where you've talked about what you can and cannot do, where you've, said air and water. Like, I used to get NAFS letters all the time when I was in manufacturing. You hand it to the building official, you'd see the stamp and go, thank you. They didn't even read the paperwork. And that's about 80% of the market right now for enforcement when it comes down to it. So I think if there's some place to go with this, it would be EGBC to start creating some guidelines on how to address these issues. Right?
Been some recent changes in the professional acts for AGBC and AIBC. And in Part 9, they can only, you can only ethically use schedules on structural and geo. So you get in there and you get asked for schedules on your window. You can't touch anything with the structural on those schedules. You can't actually seal the documents and include in schedules wind, water, air, any of that stuff.
So Burnaby came back to me and said, there's a part in Schedule B. This is when you go to B, like SB, like not the supportive documents for schedules. They're actually asking for the full schedule, which in there has a section for environmental separation. So they're asking one professional to provide a letter of assurance that it deals with environmental separation and the structural of the window.
Yeah, but you can't.
I know.
That's an
what I told
illegal
them.
use of the schedule. All you can do is an alternative solution on everything except the structural and the geo.
Yeah, but because it's there, they're saying, oh, therefore you can't.
So because there's a Harley out there, I'm allowed to go grab it and ride it. I mean.
All right. Anything else? Okay, well, that concludes our programming for today. Thanks to Kyle and David. I think that was a really great session. Thank you very much. Appreciate it.
I just want to say thanks also to, Westeck for allowing me to come here, from RDH and to present with him for all that they've done, as well as, Fenestration Canada. It's a great opportunity as an engineer to, give back. And so I appreciate the opportunity.
Great.
Thank you.
Thanks, Dave. Yeah, thanks for everyone showing up. I hope it was informative. I want to thank the Westeck crew for helping set up, and Candace for the lunch. I'm not sure if she's still here, but I do want to make a point of directing people to our showroom. I hope everybody can go. We'll all be heading over there. I believe the address 8104 Evans Road. Pardon?
Evans Parkway, 8080.
That's right.
Oh, that's right. It's
Yeah,
front
8080
building,
Evans
yeah.
Road, front building, yes. I don't know if people can join us there. It's maybe a 3-minute drive east. Come check out some of our new products. And I think that thank you for FenCan for allowing us as Westeck the opportunity to put this on. I hope it went well enough.
Yes, and again, thanks from Fenestration Canada to the people that attended today. This is an event put on by the Pacific chapter of Fenestration Canada, of which Kyle's the chair. Thank you so much to Westeck for hosting. Thanks for lunch. Good venue. This was really well set up, Kyle. Thanks to your team. Did a great job. Our sponsors, Sherwin-Williams. I think Maria's gone. Martin from JSA Machinery, Craft ERP, Amesbury Truth. Am I missing one? Thanks to Murray for his session and for the audio video. Really appreciate your support, Murray. Murray's a great FenCan supporter, has been for quite some time. Thanks to our FenCan team. They're going home tomorrow, back to Toronto and Quebec and Montreal, Quebec. No, Montreal, Victoriaville, and Victoriaville. And I'm going to go over to the showroom. They have some cool new products that I participated in years ago in the early stages, and Kyle and his team at Westeck has brought them to fruition. A 90-degree patio door that's also a pocket door. The new awning serving windows that are becoming very popular. So I'm going to pop over there for a bit. Happy to chat with anybody that wants to talk. Thank you so much for coming out. We really appreciate it. And we'll see you next time out.